everybody. My name is Scott Davidson, and I'm work at McNeel and gonna conduct part of this workshop today. And then Ehsan's probably next to me in the thing here, and Ehsan is gonna do actually most of the workshop. So it's good to see everybody here. We have some other people here from the Rhino-Inside.Revit team, and one of the things that I hope you get more familiar with after today's workshop is just all the resources and the people that you can ask questions to. Jaffe Alton is somewhere in the thing. Anyway, Jaffe's up on the discourse forum a lot and has done a lot of architectural fabrication work. And so he may jump in today if there's some questions he can answer. And Quique Garcia is in front of the palm tree out of Barcelona. It's late night for him right now. Quique's doing a lot of the back end development, and he's you'll see him up on the forum and things too. So between the four of us, we hopefully can answer all the questions that you have. So today's workshop, it's only 3 hours long, and what we're going to do today is I'm going to start this kind of as a practical, pragmatic look at Rhino-Inside.Revit. From the survey results, we noticed that we have a lot of Grasshopper, people that are familiar with Grasshopper or Grasshopper experts, and there's a lot of people here that maybe aren't as comfortable in Revit. And I know there's a balance there. I mean, I know people kind of are not all the same based on the survey results, but generally what we're looking at today is I'm going to start with going over Rhino-Inside.Revit and the interface, how things are organized in Grasshopper, kind of from a Grasshopper Rhino person's perspective. And then as time goes on here, as the workshop goes on, we're going to get more and more into the Revit database, how Revit's organized. And then Ehsan's actually going to take the last couple hours to talk a lot more about Python, working in the Revit API, using Grasshopper component to, creating your own Grasshopper component, scripted component to make Revit do what you want it to do. Because one of the things that we've noticed is that while we have a lot of components and you can solve a lot of problems there, it's really helpful if you can create simple Python components to solve some of the problems that you have. So this is gonna move from, fairly simple into more working within the Revit API. And what's nice is if you understand more, the more you understand the Revit API, the more you actually understand why the Grasshopper components are the way they are. And so they kind of go hand in hand. The Grasshopper, you can think of Grasshopper as a development language. And so they mirror in some ways, or in a lot of ways, they mirror the Revit API. And anyway, we noticed that was, and one of the things that's I guess important to understand too is that it's important if we're gonna create workflows that we understand both Rhino and Grasshopper and Revit pretty well. And so we're trying to balance those two understandings based on these survey results that you have. So hopefully it's useful. Hopefully it allows everybody to be more flexible and solve more workflow problems when you get done with this workshop. It will be recorded, and so you'll be able to reference it later. All the stuff we're going to show today, you can actually find the documents now, or we can make sure to get them to you. So move forward. And we'll have time for discussion. We'll have some time for show and tell, hopefully, in all these 3 hours. So, okay. Any questions about that? Okay. So let me just share my screen, and I'll get started with the introduction, and we'll see how that goes here. And I know the beginning of this, a number of you know already, but I'm just laying the groundwork so that we can get more and more. We can just make sure everybody kind of has a little bit of background. I'm also going to touch on a few points that we find we get a lot of questions about, and make sure that we cover some of those things. What this takes, I think Rhino-Inside.Revit runs in 2018 through 2022 now. You install Rhino on the machine, you install Revit on the machine. You don't have to do it in this order. And then once those two are on the machine, then you install Rhino-Inside.Revit, which you can download for free. It's an open source project, and you install that. And what that does is that it installs this toolbar here. And so from this toolbar, we can do everything that we need. Currently, it's important to understand that Rhino and Rhino's not running quite yet. So it's not taking a license. And of course there's Revit. Once I hit this button and it loads the rest of these toolbar here, then it uses a Rhino license, because what it's done is it's actually taken Rhino and it's loaded it inside Revit's memory space. And so now it's still technically one application, it's Revit, but now Rhino is running inside the memory space of Revit. A few important pieces up here that I want to cover. One is we have this little red dot here. This notifies you that there's a new build available. And depending on which build you have, this will allow you to understand that there's a new build, kind of using a Revit technique of showing that there's a new update to the plugin. For those of you that work on Revit or Rhino-Inside.Revit, there's a few different builds. If I hit this more button here, I have the about, I have guides, which gets up on the website. We have the forum that you want to go to. Some different documents that we find useful when you're working with the API and our stuff. But I want to go to this options page here. And this is the key to kind of administering Rhino-Inside.Revit. You can have it, load it, start up, different things like that. But the biggest piece to understand is that we continue to actively develop Rhino-Inside.Revit. And there's different builds available all the time based on who you are and kind of how new and on the cutting edge you want to be. So if we go down here, we can see the three builds. We have the public release, which we release currently once a month. And that one is, the tested version, the most stable version of the build we have. We have a release candidate. So the release candidate comes out every week. Technically we have a month to stabilize it before it becomes public. So we try not to add new features. We just are trying to make it more stable, make sure the new features we threw in that can be stabilized and if there's any issues or anything like that. So that one comes out every week, but it's pretty much the same from 1 week to the next, other than stability fixes. This is a very good build if you want to make sure, if you are, for instance, you need to roll out the stable version and you want to test it before you roll it out to the rest of your team. This is a really good place to test it. If you find you can see what we changed, you can test that really quick, and it's a great way to get back to us, because in the next week we'll have another build of it, responding to your testing. So that's a very nice one to have. Then the daily builds are what they sound like. They're just the most current build from whatever we checked in today, yesterday, whatever it might be. And it's the one that may have, it has the newest features, but it also may have features that are unfinished. It may have features that are partially put together. We've been in situations where we've drastically changed some of the components. We try to avoid that when we can, but that one's really, really on the cutting edge. And so that's kind of understanding which build, and we expect, you know, firms to have different builds. Like some people may have public releases and other people might have release candidates, for instance. And then some people that really like to experiment and have the newest may have daily builds. And so anyway, that's important. And then to update, it doesn't download and install automatically. You'll get that red button. You'll come here and you can download the installer from here if you want to update. So is that good? So anyway, just important to understand that this is here and that's our build process. It's a way that we can get testing of the product in the field without impacting everybody that has it downloaded, because some people, you know, they want to just be on the stable and that's it. So anyway, so getting back to how this loads, you know, you get to this part here and I'm going to press this button. And now what it's going to go through the whole process of trying to load Rhino and Grasshopper inside Revit's memory space. And this takes a lot of DLLs. This takes a lot of work in the background to get this loaded. And one of the things to understand, and this is another kind of thing we get a lot of questions about, is troubleshooting loading. So at this point, what we're going to do is we're going to come in here and we're going to load everything. And this is the point where we find we get loading problems. And most of the time, it is a conflict between something, a plugin in Revit, and what Rhino's trying to use. So for instance, Revit has a plugin to read a 3DM file. For instance, this is an older problem, we fixed this, but Revit has an older 3DM file importer that it loads all the time. And Rhino, of course, has a newer one. And those would come into conflict when it tried to load. Another example is Enscape. If you have Enscape plugin loaded in Revit and you have the Rhino Enscape plugin, they're actually crash into each other because now we're loading in the same memory space, right? So these are kinds of things, and what we're doing is when you have those load conflicts, some people find that they can unload one of the two because they don't actually need it. Some people, what we're doing is we track down those companies and we work with them so that it can be loaded together, because it's obviously most people haven't tested, you know, loading one application inside the memory space of another. So if you see that, if you have that, and a lot of times it doesn't, you know, we've gotten pretty stable in that it doesn't happen on most machines, but you might have one machine in the office or two machines in the office, and it's important to kind of look at maybe the plugins that are both in Rhino and in Revit, and let's see if we can find let's see if we can find that conflict. But that's an important part of the process that we get a lot of questions about. So it's important to understand that. And one of the things I want to talk about here is that the Rhino.Inside.Revit website here is, you know, this is what we have here. If you come out here to reference here, you can come out here to reference, and there's like troubleshooting, known issues, these things like that. So if we have, you know, here's where if we have the question a lot, you know, we'll put it out here. So this is a good place to come out and look at the known issues. We have some tools to look at troubleshooting the plugins, for instance, things like that. You know, that's all in here. You know, all about how to deploy it. And then, you know, up here we have the forums too, if you want to ask us questions, because we're always on the forum. So, so anyway, just to know a little tour here of the tools we have. We're going to go. We'll be in here a little bit more today, so that we can continue to reinforce the idea that, or show you what we have from documentation point of view. So, okay. All right. So now we've loaded this. These have all come up, and we're going to. I'm just gonna look at a few pieces here. If I load Rhino, Rhino comes up here. It is Rhino. The difference is that Rhino knows that it's running inside Revit. And so, for instance, when I load Grasshopper, oh, this is one of the things I want to show you here. This is actually, so when you load Grasshopper or Rhino and the quote units mismatch between the two, this will come up here. Now, one of the things you can do here is I can change the units here from one to the other. But it's important to understand that all that this is really doing is answering the question of what units you want to see. It doesn't change the way the two products actually transfer information back and forth between each other. We do the translation of feet to inches or centimeters to inches or millimeters to feet or whatever. It just depends on if you want to see millimeters in Rhino and you want to see feet in Revit, or you want to see, that's what this is really talking about, is that you're going to see on display different units in one product than the other, but it doesn't impact the actual size of objects. You're not going to get the wrong size object on the other side. Now you have to be careful, to remember what units you're in Grasshopper, because Grasshopper doesn't, it just works on values a lot of times and doesn't actually have units with it. But, it's going to work on the Rhino side of units, depending on what Rhino's displaying. So, but anyway, this isn't a big deal when you see this, and you can actually say, don't show me again, but just to understand that it's not actually doing this, it's not changing the way things are scaled, depending on how you answer that. So, so we have Grasshopper here. So this is a place that, based on your survey, many people in this workshop are really familiar with Grasshopper. So I'm just going to go over it really quick to look at the Revit piece of this. So when Grasshopper loads inside of Revit, there is this little toolbar here on the params page, and these are all the data types, raw material pickers, all the raw params for Revit. So graphic elements we use all the time. Sometimes, we use the category one, different primitives here, like you might expect, Rhino primitives like B-reps and curves and points are all on this tab, okay? The other place to look is the Revit toolbar here. There's a new toolbar here, and this is where the majority of the Revit information is. Things like, this is very new, the assemblies, the ability to work with assemblies in Revit. This is where you would build native Revit objects from Grasshopper. So if you want to add a beam or a column, add a adaptive component, or add a type, insert a type, or in a place, add a floor, roof, add railing. And this is an area we'll continue to add as we can. I believe in 2022 we can do add ceiling now in some of these. I'm running 2021 here, by the way. We can work with categories. We're going to talk about categories in just a minute, and how they relate to Revit and how they relate to Grasshopper. These are custom Python components. So one of the things you're going to see with our process is that Ehsan, especially, when we make prototype components, a lot of times we'll do them with Python, and you're going to see on the web page, you'll see where those are on there. They're big red buttons you can download. And when you download those, they actually show up here in this custom toolbar. So there's direct shapes, which we're going to talk about in a minute. There's how to get into the document itself, and how to identify the document, work around the document. One of the things that's really nice about Grasshopper and Rhino-Inside.Revit is that it will work in one definition will work across multiple documents in Revit. So you can match information in two documents. You can take information from one document and push it into another. You know, there's a lot of different kind of things you can do to talk to multiple documents. We're also going to talk about how to access those documents. Elements. Once you break down past all the database of Revit, you end up with an element, whether it's the door itself or the wall, or you know, just an element inside a family, and so you can work with the element directly here, and so you know, we'll look at that. Working with families, we'll talk a lot about families today and how they fit in the hierarchy of how we see them fitting in the hierarchy of Revit. Filters, these are selection filters. I think Ehsan is going to go over these in the second hour a little bit, because there were some questions on the survey about them, and they are something that the Revit API does use a lot for. Dealing with the hosts, one object can own another object in Revit, so that the host is the parent object. Input, these are all the pickers. Like if I want to do, I want to pick a category, or I want to pick an element type or an element class, or I want to do a level of detail. I want to pick what that is. That's what these pickers are for. Materials, these are rendering materials. Can I add them? Can I edit them? Can I interrogate them? All of those things, that's all in this place here. This is just model, parts of the model that we, you know, kind of fall in between things like grids, levels, you know, the modeling group. You can make groups, you know, line patterns, dashes. So this is kind of a miscellaneous kind of category of things that have to do with the model, but they're not necessarily like, you know, specifically families or something to build. This is dealing with parameters. Parameters are really special in Revit. So, you know, creating parameters, creating shared parameters, built-in parameters, all that kind of stuff are here. This is looking at rooms, which Ehsan will look at later today. Site objects, you know, topography, things like that. Types. So types are kind of, you know, a subset of families. And so we'll look at, we won't look at that a lot, but we will talk about that today. Views. This is an area of very active development for us right now. And so, you know, I saw in the survey some questions about views. I don't know how much we're going to cover today, but we will talk about what we're working on at some point. And so this is where we can, for instance, these are new. You can create a sheet now. You can create a title block. You can kind of query what sheets are available, things like that. The obvious thing that's missing here is adding a view to the sheet, but we may be able to address that by the end of this one. And then this last one here are walls. So walls are such a big category and so specialized that it kind of got its own group over here. And this is where we deal with just basic walls, stacked walls, curtain wall systems, all of those things. All those things that have to do with walls are over here. So are there any questions about this? So just a quick survey of where things are. Okay, so I'm gonna jump in here and we're gonna start talking about how these two products work together and how you can start using these components to create something in Revit and in Rhino. Although I'm really going to push. We're really pushing Rhino Grasshopper into Revit today. We're not talking a lot about bringing information out of Revit into Rhino. We can do that, and a lot of people do that, but that seems to be much simpler. People kind of pick up on that pretty quick. So we're going to work on the harder, more difficult piece of how to work with Revit's database from Grasshopper. So I'm going to open a model here that some of you may have seen. Let's do this one. I think. Yeah. So this is a good study in how to use this. So this is a model done in Rhino. Pretty standard stuff. These are just, footings that are NURBs. These are just extrusions that are columns, and all these pieces. And I broke them up by layer. And so there's different ways. One of the things that, and we may discuss this by the end of the thing. There's a lot of ways you can stuff information in a Revit model or in a Rhino model, and you're going to find that Rhino-Inside.Revit demands and pushes you to try to find ways to put more and more information in the Rhino model so that you can organize it properly in Revit. So in this case, I'm just using layers. So I have these layers here, and these layers are reflective of the category that I want to use in Revit. So I'm using, in this case, layer names, and that will move across to Rhino or to Revit. And I will open a, let's see here. I will open a model here. Let's see what I get here. Okay, so this is the definition, fairly straightforward. I'm going to go over it in detail here in just a second. And if we look right, yep, so you can see that it actually took this model here, and it's generating the Revit model over here. And what's important to understand too is that this is live. So if I was to change this Rhino model, this Revit model would update. But more importantly is understanding how the Revit database is put together, or how we view the Revit database being put together, and therefore, how you have to break these down to work. So the important part here is that Revit has, there's three main ways to get Revit geometry or Rhino geometry into Revit. And the first way, and the simplest way by a long shot, is called direct shape. And so in Revit, you have categories. Those categories, you can imagine categories are, in Rhino, they're like layers. So, but in Revit, they're categories like walls and windows and site objects and structural foundations. In this case, I'm using. And so you need to specify the category that you're going to work in Revit. Here's the really difficult part about Revit, is that different categories act differently. That's actually not the category, I guess, it's kind of weird. So categories, like different categories, some categories can be more stringent, some categories can be less stringent. It's actually, I guess, the families within those categories that are really stringent. So, but you have categories. And so like there's, and in all the categories, pretty much all the categories can take a direct shape. And so a direct shape is you can imagine it's just like floating a Rhino BREP, a Rhino solid, a Rhino mesh in that category. It's like just like simply putting a Rhino object on a layer. And while that works fine and it works great for things like maybe you're going to do a competition and you want to just do a quick drawing from the model, but you don't really want to put all the BIM information on there, a direct shape in a category works fine. But there's a lot of limitations to direct shapes. It doesn't have all the information. It's not as smart in terms of the way it draws its objects. It can't necessarily take subcategories, you know, and categories can be just like in Rhino, Rhino's layers, categories can control how things draw in certain views. They can do things like how, you know, how things get hatched, you know, different pieces like that. So one of the things you're going to start thinking about is how do I want this object in Revit, this element in Revit to act when it gets cut, when it, you know, does it poche, does it not poche, those kinds of things. That's very, very important. That's actually one of the whole reasons we use Revit, right? So the category, so direct shapes are fine, but you're going to find a lot of your BIM managers and things like that only use direct shapes when there's no other option. And because it kind of makes a mess of the Revit database, and they're not as nice. It's harder to apply standards to them, all that kind of stuff. So what the next level down of organization, that inside each category there is you create families, and everything in Revit, pretty much everything in Revit, especially it comes in Revit, is part of a family. And that could be a 2D element, that can be a 3D element, you know, your title block, your sheet, those are all actually kind of families. So we have category, and then we have family. And you could think of families from a Rhino Grasshopper point of view, you could think of families as a block definition. So it's a block that has information in it. Some families are really simple, like component families. You know, they're just like a block, you know, that they have one definition in them, and that's it, just like a Rhino one. If you change that family, all the inserts in the model of that family will update. But Revit also has system families, and they have parametric families, so they can have objects that they differ from one insert to the next, even though they're part of the same family. You can take your family, and you can create a series of pre-made parametric models. Those are called types. And and then you insert it. And the reason I'm going over this is it's very important that you understand that hierarchy when you're using Rhino inside Revit. In Revit, you have categories. Categories contain families. Families are just the definition. They don't exist. They don't exist in the view yet. And then you have types. So you always have family, type, instance. And so you're going to always want to use that. So here I have, this is a new component family. And here, if I come here, that's new component family. It's this component right here under families. And you're going to see that this family takes everything that a standard Revit family. We're going to have here a template. So families have different behaviors. That's what makes Revit extremely complicated to understand. A wall family is very different than a structural foundation family, very different from a site family, very different from a roof family. Some families are very flexible, and some families are very sophisticated, but not flexible at all. And so one of the things you need to learn as a Grasshopper Rhino person is which families can you use, which families are essentially so locked down that you just have to use them like Revit. But we have a template. So every family gets you get a little template here that kind of lays down some of the behaviors. And you can see here that Program data, Autodesk, in this case, I'm running a 2019 template, family templates. All those are there's always a common place where all the templates are in Revit. And so I'm feeding that into this here. Families, you can decide whether you're going to overwrite families or overwrite the parameters. This is just whether you want to keep the families locked. Some people like to lock the families for teams, so teams don't accidentally change the families around, because you can pre-program a lot of behaviors in those families and you don't want those changed. So that these are Booleans, whether you want them overwritable or not. This is the name of a family. So the name comes in here, and I'm calling them canopy footings. So you need to choose your name here. This is the category. So I used a category picker here, built-in categories. If I click on here, you can see there's a few, there's lots and lots of categories. They have, what's important to understand with categories is you cannot change the top level categories in Revit. You can't add one, you can't change them. You just have, there's just a series of hard-coded ones, and that's all you get. You can create subcategories underneath some categories, but you can't create a new category. And that can be kind of frustrating. It's like saying in Rhino, there's a series of top level layers that we have specified and you can't change them. But you can create sub layers. And so that's kind of the same thing here. And we'll get into subcategories here in a minute. All right, and then I have the geometry coming in from the component family. So this creates a family. Now, as we talked about before, with every family, you have to have a type. And so all I do is I take we just take the types component, we throw it in here. What's interesting is a component family. If you create a family, a standard family with Rhino-Inside.Revit, it only has one type because there's no parametric objects in here. For those of you that know Revit, there's no actual parametric objects inside this family. It's just geometry. And so you just have one type. I take that one type, and then using the add component by location, I can create the, I can insert the object in the model. And so that actually creates, this insert piece is what actually creates the inserted element here. This is the insert. So this is an insert of a type from a family inside a certain category. So does that make sense? That hierarchy? Okay.
Totally.
Yeah, good. All right, so we're going to get a little more complicated here, because one of the things to think about, we talked about wanting to make drawings. And so one of the things, you know, always thinking about, you know, how are these going to look in, how are these things going to look in Revit from a drawing perspective? And so when you're in Revit, the the line types and the how everything gets drawn and cut, and if we go to elevations here, how all that looks, that is all based on category and subcategory of objects. And so if you want to change the way things get drawn in Revit, you need to be really familiar with how things are getting categorized. And so sometimes you want to send an object over that's complicated, but needs different, what they call subcategories, so that each one of those sub-elements, I can change their graphic, how, you know, what color they draw, whether they hatch, how they hatch, all those things. And so what we do here, or what I did here, is that for the rest of this canopy, not the footings, but for the columns and the roof and the structure underneath, I had to do some things that I had to make subcategories. So if you come in here, again, I can't, there's not just one, the category, the overall parent category of that whole walkway has to be something other than roof and wall and ceiling, because those categories don't take subcategories and complex. They have their own complex families, but they don't take freeform families like what Rhino can produce all the time. So you have to find a category that can take that information. And in this case, I used the site category. So I found a category that takes subcategories, site's one of them. And then what I did was I took the layers, in this case, the Rhino layers, columns, roof panel, roof beams, frame. And these are layers that I just typed them in here to match the name of the Rhino layers. You can get, smart and actually grab the layers from Rhino and pick them and all that stuff if you want. And then down here, I created a list, same index of the names of the subcategory: canopy columns, canopy panels, canopy beams, canopy panel frame. And so that the Revit technicians or the Revit person or the Revit model, as it goes downstream, they'll have these subcategories that they can change the graphic properties of the objects on those. So they could change the panel graphically, how the panels look from the way the beams look, from the way the columns hatch, for instance. And so understanding kind of how you want to break that down is very important here. These are just render materials down here, which I also lined up per layer, but I'm going to skip over that piece right now. It's important to understand that as you're going from Rhino to Revit, it's important that you understand how to subcategorize your pieces or categorize them in general. So what I do, I just using a key value search here, I changed the word columns to column canopies, or canopy columns. Roof panels, I changed to canopy panels. And I feed them into a subcategory. I create a subcategory of them. And so we're just taking the site, which is the parent, and the name of the subcategory down here, and it will create that subcategory underneath each one of those parents. And so you can, if I go into category here, add subcategory is the component I'm using here. All right, so I have to create the subcategory, the container in Revit first. And then what I'm going to do is, before I create the main family, I can create a form, an object that's ready for a family, but that contains a subcategory also. So that's a family form that's under families here. Component family form. If I wanted a component family curve, I could do that. Component family opening, component family void. I'm using component family void form. And what that contains is, it contains the geometry, which is, this is a BREP. This is an important part about families. Families only take NURBs. They'll take points, they'll take curves, and BREPs. What they do not take is, they don't like meshes. So, you want everything to be a BREP if you're gonna send it into a family. Whether it's visible or not, whether the object itself is visible, the sub-object, the subcategory that you have. So this is what's going to give us a little bit more fine grain control over that element in Revit. And then the material itself. And this is the visibility of the subcategory. So, the object itself could have a visibility flag, but then also the subcategory can have a visibility flag too, within the family. So this is a family form, right, that you have. And so and I create a series of these, right? So I'm creating 4 different subcategories and objects, and an object and different objects on those subcategories. So I take all those family forms and I can push that into my standard new component family, which uses the site, so I'm using the site category, I'm using a site template. The family itself is called walkway. It is part of that category, and then it has all these family forms. So you can think of family forms as not only just the geometry, but also so that BIM information, a little bit more of that BIM information surrounding it. So now we have our definition, our family. We grab its type, and then we insert it back into the same place it actually is in Revit, in Rhino. Rhino and Revit, they're both in exactly the same location. So we're not doing anything fancy here. Once we insert it, we just insert it based on the same location it originally was. And I'm over here. And so if I can come in here, and you can see what I can do is I can come in here, and this is for the Revit people. Now I can come into graphic display options, or not, I'm sorry, I want the other one, the visibility graphics overrides. And if I come down to site here, and I open that up, you can see I have canopy beams. In fact, I've used this model enough, I've got duplicates, but, and I can come in here, now I can override the lines, I can override, how those draw based on those subcategories. And based on whether you are in a, you can do the different patterns and different, depending on which family you have and what kind of drawing you're in, you can change the way things get hatched and things like that. It's important to understand too that these are actually NURBS objects in Revit. These are actually nice solids that if I didn't have Rhino around, I could actually come in here and edit this family, and you can actually do some simple editing on them in Revit without Grasshopper knowing. So if you were to disconnect Rhino and Grasshopper, they're good Revit objects that you can use. That regular Revit, somebody that just uses Revit, doesn't have any idea what Rhino and Grasshopper is, can actually edit these things. Of course, if you were to try to apply Rhino and Grasshopper to this model later, these things would get updated back to what Grasshopper wanted you to do, and it would make the changes, right? This isn't a two-way thing. So, any questions about that? No questions, really. Okay. So, so that's the biggest thing to understand with this, and to get your head around how Revit is organized. If I go to, I just want to show you the main document for this, the main guide for this. If you go to our website, you go to guides, and it's Rhino to Revit. This guide here is the guide that talks about all of these things, shows you them, has some videos on it about all this, but you can see how we can get to the point where we can control how the drawings look in Revit from Rhino. And what's nice is if I update the Rhino model and the Grasshopper model, these drawings will update too. And so somebody doesn't have to go in and redo, how these things look, because they just get updated properly. And then the last piece of this is that that other than using component families, we can also go in and create, if you want to add a beam or column or a component or a floor, like a floor, for instance, takes a boundary. So you would have a boundary in Rhino, and then you can create a floor from that. So some of these you can create native objects in Revit just by using some of the raw materials out of Rhino to create them. So, All right, so that is a quick overview of the organization here. I want to talk about geometry translation here in a second, but are there any questions that people are thinking about, or any kind of if you're thinking about some workflow problems you have with families and things that you have some questions about, maybe we can answer those. Ehsan and Jaffe and Kiki and I can maybe take a look at that. Any workflow issues? I'm going to stop sharing here for a second. Well, I'm not going to stop sharing because if you have a question, but what do you have? Anybody have a question about? I saw some on the survey about families, parameters, things like that.
Hey Scott, there was a question about sub-Ds, specifically in Rhino 7, and how they could be sort of like translated and brought into Revit models.
So sub-D models get translated into NURBs. You know, our sub-Ds, there's always a one-to-one correspondent between sub-D and NURBs in Rhino. And so you get it translated to NURBs, and then that gets inserted in Revit as a NURBs model. It works pretty well. You have to be a little careful because, of course, you can make a sub-D with thousands of patches, and you need to, you know, you can overwhelm Revit a little bit when you do that. But sub-D should come across fine. There's something called packing. When we go from sub-D to NURBs, we'll pack the patches together into larger patches, so there's less patches. And that really helps a lot with using sub-D. But in Rhino, it'll be a sub-D. In Revit, it'll be a NURBS. When you change the sub-D in Rhino, it'll translate it into NURBS and into Revit. So that should work fine. And that's a good, accurate conversion because it's, yeah.
Oh, sorry, Scott. Another question that I think was kind of important too was the sort of like this notion that these Grasshopper components are driving elements that are owned and created by Revit. And how do they behave when you rerun the Grasshopper definition? Like, for example, in case of families, it would there's an option to override the existing. And in case of a wall, for example, if you change the height, it'll not necessarily recreate that component and just will change that property. So like maybe a little explanation on that would be helpful.
Right, and this is where things get real dicey, and it just takes, it just takes some thinking about it and learning about how different categories work. So walls are a good example. Walls have a lot of hard-coded properties, parameters. So they have a center line, let's say. Let's just simplify the idea of what they are just to even talk about it. But they have a center line, and then based on that center line, you create a wall, and the wall has height, and it has a width and material and layers, and and all those things. And you can think about everything beyond just the line itself, that center line. Everything is a parameter on that wall, as a wall style, and that style has a bunch of characteristics. And so if you wanted to change the height of the wall, you're actually not touching the family definition itself. The walls kind of have their own built-in families because it's a system one, but you're not touching the family itself. What you are doing is you're changing the height parameter on it. So you're going to come back on the object and you're going to say, give me its height, I want to set its height parameter. And let me see if I have an example. Yeah, I might have an example. Let me show you how you do that. So just gonna close all this here. Let's get that out of the way. So it's important to understand, like, Like if you were to create, like you can't, and this is actually, I saw this in the survey too. If you create a family in Revit that has sweeps and extrusions, and it has objects that have parameters, you're not going to overwrite that in Rhino. You don't want to. But what you can do is you can set all those parameters with Grasshopper later in the process. And that's what you want to do, is you want to actually set those values in either on the type or the insert itself. Let's see here. I got that open. Now we're going to go over here. Open. So we have a little simpler model because we're going to create native elements on this one. And we'll open this up. So we'll come in here and do well, this one's, I guess this isn't exactly what we wanted to do here. Like in this one here, so I have these columns here, and I have this roof. This is a Rhino roof here. So if I pick it and I change the height there, you can see that the columns are changing height with the roof. You know, so as I move it up and down in Rhino, the columns are changing height, and that's true in Revit also. So we do that, and let's do this. So you can see as I change them, those columns update over here. And the way I'm doing that is that I'm actually creating a column, a system family, like a family. You're not actually you're just rebuilding it. And so what I have Rhino doing is Rhino's actually going through, finding the box, intersecting those lines, figuring out how long those lines need to be, or in this case, a point at the bottom of the box. And then I create a line of a certain length, and then I feed it back into add column. And so what it's doing, it's deleting the old columns and it's recreating new columns. It's actually replacing them when possible and keeping the same ID. But to specify what kind of column I want, I grab the column category, and then I can pick what types. I can pick what types are in the model. In this case, I have 6 built-in types, so we can change the column type. But then it actually comes in and it actually recreates this. If I wanted to change a property on a column, what I would do is take the columns themselves and run them through a parameter. You know, you can run them through what parameter you want to change. One of the things that is nice to look at is you can go through and you can actually look at all the information about the element. Where is this here? Inspect element. So this one's really, really, really useful. If I go to element and inspect element here, I'm going to push this into here, and if I double click on this, I
think it was we turn it into shift click, Scott.
Shift click.
Yeah.
So if you do, you hold down shift and you double click on this, this gives you all the parameters that you can change on an element, right? So that was under element, inspect element. And if I use it, like let's say that I want to change the mark number, or I want to change it to created, or I want to, in this case, I could change the base level or something like that. I could bring it out here and use it. And if I happen to be using that there, when I do shift, double click again to control, I mean to bring it down, then it'll leave this one available to us because it's one that we used. Shift, double click, and now I can get back out to all of them, and then I can compact it here. So that's a way you can find out what parameters you're going to change. So there was some question about how do I make parametric families. You can't make parametric families currently out of Rhino-Inside.Revit directly. What you need to do is create the families in Revit using Revit's tools. And then what you're going to use is you're going to use Grasshopper to change their parametric parameters. That makes sense. So that's how you want to create parametric. You have to create the parametric families in Revit, and then you can actually change their parameters using Grasshopper.
Scott, this is also a good time to segue into talking about the similarities between a Revit project document and a family document, and the fact that Grasshopper can operate in both of those or multiple documents at the same time. There's a question about how can you get Grasshopper to work inside a family. So like maybe like show how the active documents work, and then the document inputs on the components, that kind of stuff we can talk
about. I'll do that. Let me jump back to that other definition because it's the easiest one to see how this works. So for those people that are used to or not used to Revit, it's important to understand that those families, we call them blocks. They were like those family definitions. Families are actually, you can imagine, they're most of the times they have family files and they have project files. And so families have their own files. The family definitions have their own files, which you can kind of reference into to Revit. You can open those separately. So when you open a model in Revit, you can see that you can open a project, which is the project, or you can open a family. So that's like one block definition, a family. And so in Revit, you can have multiple families open, you can have multiple projects open. And so if you think about a family, think about it as a block definition that you can reference into a project. They do have built-in families, but technically always, if you thought about them as separate files, that's the best way to think about them. And so if I come in here and let's close this, let's get back to that one I had here. And here, here. Okay, so if I want to, so this, you can see here, see how the family, it had a file here that has a separate piece here. One of the things that you're going to see on almost, well, on a lot of components is if you zoom in here, you get an extra plus right at the top. And if you click on it, you will get the ability to input the document. So for instance, if I wanted this family to be part, instead of being built into the project, which some people don't like to do, like if this family was going to be referenced across multiple projects and things like that, you can come in here and hit plus, and now I can specify which document I want to talk to. And you could open a family document here. If I open a new family document, you'll see it looks a little different, has a little different behavior. Let's see here. Just pick up something simple. Well, these aren't this is, yeah, I just have these families here, but so you can see here, I'm in a family, a generic model family, but they're a little different. They have a little different object or view. They look the same in a lot of ways, but it's just essentially a block insert with that information, and that's different than the project itself. So one of the things you want to do is jump in on either your family component and hit your plus symbol to get to the document. Most of the time, if this isn't filled out or yeah, you don't have something else, we're going to go to the active document. So whatever the active document is, this component's going to work on. But if you have multiple documents open, or you like Ehsan says, you want to actually go directly into a certain family document, you can hit the plus symbol there and open that up. Let's see if we have other ones. Yep. So see, this is an example where I could take a family and a type, and I could actually insert it into a different document. And so, so by default, it's going to insert in the active document. But if I hit plus him, it will go into a different document that I have open, right? Obviously, it can only go into open documents, but does that make sense? So this is a little secret that's for people that are advanced, like you all will become, knowing that there's the little plus symbol at the top of these or the ones we've written, and that a lot of times allows you to go into a different document. Okay, does that make sense? Like this one doesn't have that, to go from a family to a type, because the family has to be loaded into the project before, and then the type just pulls from that family. Does that help that a little bit? How to work with multiple documents? It's really just using this and expanding.
Yeah, and now once we get to talk about like the API and stuff like that, I can actually show how you can collect the open documents, that kind of stuff, and
right.
sort of like work in more than one document in your Grasshopper definition.
Right. And there is the active document. And you can get open documents here. So if I want to look at what the open documents are, I have one project open, and I think I have one family open at this point in time.
Yeah.
But you could use that to start to get the names and index what you want.
And if you, there's also an active document if you just want
yep.
your definition to sort of like work with multiple documents, but also get a reference to whatever that's active.
That would be this one
that gives you active document.
Right. And this one's good too. Like sometimes you want a definition where you actually want it to go, you want it to sometimes go in the active document, sometimes go in some specific document. And so you can use this active document to actually override whatever that was set to the active document. Even though by default, if you didn't have this, it would be the active document. Okay. But that's all under document. So any other questions, Ehsan, that you see?
No, really. There's another one that talks about creating parameters inside families that I'll have an example in the API section that I'll talk about.
All right, great.
I'll kind of show you how you can create families, create parameters inside a family definition. So this way they can have a Grasshopper definition that creates typical parameters that they need in multiple different family types, especially for the people that manage families for a firm, that kind of stuff.
Yeah.
There's a lot of times that you have to do work for a specific client, and they want a certain schema, a certain type of data on their family instances. So you kind of have to make sure that you create the same set of parameters as defined generally by the BIM guidelines of the client on those instances. So these kind of like automation tools are actually super, super helpful.
Yeah, and like I said, if we can get everybody here to the point where you're talking category, family, type, instance, and understanding kind of how parameters lie inside those families and things, that's going to really, really help doing Grasshopper definitions that have the correct schema so that the rest of the firm can work on that information. Hey, let's take a 5-minute break. So it's 8:15, or in Seattle here, it's 15 after the hour. We're going to go to 20 after the hour, and we'll Ehsan will start. I think Ehsan will start. Unless you want me to do geometry and tolerance real quick.
Yeah, I actually, that would be super helpful. Just,
Okay, yeah. So in 5 minutes, we'll do a quick thing on geometry tolerance and how picky and finicky Revit, what it's how to repair that stuff, and then Ehsan will keep going after that. But I'll do that piece. All right. So see you in, I guess, 4 minutes now.
Are we gonna play some background music?
Yeah, do. I'll just sing. So I'll be back in a minute.
That was good, Scott. Thank you.
You're welcome.
Super helpful. We should play some music. Let's see if I can play some music. What do we play?
Preferably in public domain, because we'll be posting this to YouTube.
Oh, so now public domain music. So if I pull something from YouTube, that would be public domain?
Probably, actually, yeah.
Huh.
We can refer to that video in our appeal.
Okay. I don't know. I don't want to play anything that would flag the video later. So
We can also edit it out. I'm just kidding around.
I'm pretty excited for the new ABBA album that's coming out.
Oh, really?
Yeah, they have
I had no
an
idea.
album called Voyage. They are going to do a sort of like a live show also, which is all going to be holograms. Them, pretty cool. The album is out. Only 3 tracks of it is out on Apple Music, but I'm waiting for the whole album to open. Yeah, it's typical ABBA albums.
That's pretty cool. Totally unexpected. I had no idea. Has they been? I wasn't following. Has they been making music this entire time, or this is like after 30-year break?
Yeah, it's been a long time.
It's pretty cool.
Yeah, it's been a long time. Wait, this one? Okay. Trying to figure out how this chat thing works. The context menus on this Zoom application are so weird. Like in every video thumbnail, there's a different set of options for the sub menu, and I'm like, just Jesus. I'm trying to find that hide non-video participants. So you click on that, then you don't have the access to the option anymore. They have to go through the top right menu, and it's there to show them. But once you show them, that option goes away from the context menu.
Yeah, the bane of my existence is trying to get the top bar when you're doing screen sharing moves to a less annoying location.
Yeah.
And there was a way to hide it, and I no longer remember how to do it.
Yeah.
So.
And sometimes it gets stuck, like instead of like being at the top of the window, it sort of like comes down and gets stuck in the middle. It's weird. Mine is like, I depends on your screen size. I kind of want to have all these thumbnails, the previews from people on the bottom, not on the side.
Right.
And like, I don't know, like Teams kind of does it nicely all at the bottom. And I feel like that should be an option here, but it's not.
Teams does another annoying thing because it has a little pill that I don't remember if it has like your name or something on it, but in those little icons on the side, it puts it right where people's mouth is.
Oh yeah.
So you just kind of see a bunch of incognito faces.
There's a lot of another thing. I noticed that Zoom added this feature that if you like start waving, it'll give you this notification that, hey, do you want to wave? Or like it shows you a wave. There's an option in the settings menu to turn it off, but you can do thumbs ups and waves, or like hand raises, sorry, just with gestures, basically.
I'm sure someone built this just because they can.
Yeah, it's one of those things that are like, let's just, record everything and try to figure out what people do in there. How many times they smile.
It's the thing. And then I guess to top on that, I think Ring Central is actually built on Zoom, but maybe a version of a year or a year and a half ago.
Oh, okay, so it's an older version.
So the two don't align either in development.
It's a different development branch for,
yeah.
I guess they're sort of like, because I don't think Ring Central is the only company that actually uses Zoom.
Right.
It seems like this has to be some sort of a service that Zoom sells to other.
Second stream of income.
Yeah. It's pretty impressive that they pretty much like sell the same application with a different icon. Good.
Okay. All right. So I think hopefully people are back. Just want to do a quick overview. Another place we get a lot of questions is geometry. How to get geometry from Rhino into Revit, into Revit's ACES. I believe it's ACES geometry kernel, and it can be a little picky. And so one of the things that you'll start to understand is that Rhino can consume about any geometry that exists out there, whether it's good or whether it's bad. Rhino will just deal with it and try to do its best with it. Revit's a lot more picky about what it accepts and doesn't accept. It has a few blind spots that become important. And where we run into this the most is when somebody, as the geometry gets more and more complicated, and especially as you get to geometry that you actually want to probably fabricate in a certain way, so the model gets very, very detailed. And Rhino can deal with that. And of course you can send that off to fabrication out of Rhino, but Revit starts to get a little, it starts a little difficult. And a lot of it has to do with geometry tolerance. And I know some people, like when you use direct shapes, I know there's situations where when you send a model over from Rhino and there's an object that it was NURBS and then it's a mesh over in Revit. And that just means that Revit's engine rejected the geometry and it meshed it. Well, if you're in a family, unfortunately, that model, that geometry won't even go across because it won't do that conversion. So I want to explain a little bit how geometry gets transferred across into Revit from Rhino, and some of the background tools we've created to make it even more, even better. But so I just have some different geometry here, and a lot of times too. Thing to think about is when you're inserting models from 3D Warehouse or GrabCAD, or you got fabricator or manufacturers models, you just get models from anywhere. You threw them into Rhino, they were fine, and then you try to take them across to Revit, and they start to be a little less productive. So I'm going to grab a BREP from Param from Grasshopper. I'm going to go over here to Revit, and I'm just going to say, let's see here, add, I think I'll do, see if we can do this with a direct shape. I think. see here. It's probably easiest one here. So if I go in here and I right click on here, I'm going to set one BREP, and I'm going to pick this right here. And so you see what you get is that it went across, this went red and it threw an error. And so what that means is I took this BREP out of Rhino and it rejected it. And if I look at this really close, if I zoom out on this, you can see that I have some yellow, there's some yellow edges and some yellow dots. That's what we've done here. And there's some edges back in here. There's some yellow dots here. One of the things I can do is I can turn off the preview here. So, well, I don't want to turn it off here. I want to turn it off on the other one. But you can come in here and you can start to see that there's some edges out of tolerance. And if you come and you go over this bubble, it says some problematic faces were removed. Geometry contains out of tolerance edges, and output geometry has naked edges. And from my experience, I believe what this is really saying is that there were faces that were too small, and so therefore I removed them. And because they got removed, now some of the geometry has naked edges in it. So one of the things to understand about Revit's geometry engine is it does not like edges that are less than 1 millimeter. Okay, so that becomes really problematic when you have models that are accurate enough to fabricate from, because of course 1 millimeter, while it sounds small, it's not small enough to fabricate from. And so what you need to do when you model things is you need to make sure that everything's modeled within a certain tolerance, but you also need to make sure things aren't too small. And so, and we'll report back what the problem is. Some faces were removed, which means they were probably too small. So, and these errors, by the way, are coming from Revit. So we send it to Revit, Revit gives us information, we throw it back up here. So, so what I would do in this case is I would explode this object and I would start simplifying. I would either make sure that these are within tolerance. I might take out some fillets. I might do something like that to start to simplify this and piece it back together. Now, when we talk about tolerance in Revit or in Rhino, we talk about tolerance. I'm going to go to Tools, Options, Units. Okay, then I have my model units and my absolute tolerance is set, in this case, to feet and some number. Okay, this tolerance I can adjust in Rhino. Rhino's tolerance is adjustable. It could be, I could have a tolerance of 1 mile. I could have a tolerance of, super small if I wanted to. The problem you run into is if the tolerance gets too small, it uses an immense amount of memory and it's very hard to join things together. And so understanding the tolerance that Revit wants, that what you want to set as minimum tolerance here is important. And so if we go to our trusty website again, Rhino.Inside.Revit website, and we go to, let me see, Rhino in Revit elements, where are we here? Grasshopper and Revit, sorry. Grasshopper and Revit, if I go right to tolerances here, okay, this talks about geometric tolerance. It talks about, and what you want set your tolerances to. 0.0039 of a foot would be good to do. If you're in meters, here's your meters that you want to set to. Here's inches. So you want to make sure you do this. Now, where we run into trouble a lot of times is if somebody just did a quick model in Rhino, they use the default tolerance, which is a little looser than this. And then all of a sudden, that general massing model, they started to model something more accurately. And it, Rhino's not complaining. Rhino's just moving right along. And then you try to move it into Revit. It can squawk about tolerances a little bit. And what you need to do is explode the object and try to rejoin it to make sure it's and with this new tolerance and make sure that it joins together. But what I wanted to talk about is some other interesting ways to do this. One of the things so the way Rhino to Revit works is that initially we take the Rhino geometry raw in the NURBS form, and we use an API call to try to recreate those NURBS VREPs in Revit. There's a way to do that through the API. And if that works, we're in great shape. And it's fast, really fast. If that doesn't work, if we send that geometry to Revit and Revit looks at it and rejects it, then what we do is we will try a secondary method of transferring the model, which is we write an SAT file out and Revit reads that SAT file back in. Okay, so we can go through a SAT file and then bring it in. We find that to be more forgiving because their SAT importer does a lot of massaging and adjusting of the model, and in order to get the model in. The drawback to that is it's slow. And so if you have, 64,000 geometry objects in there, and it starts using SAT for all of them, all of a sudden you're going to find the transfer feels very, very slow. And you can tell it's happening because up here on the command line, you'll see it says wrote SAT, wrote SAT, wrote SAT. And in fact, in Grasshopper, it will say used SAT. So it's not that one. Let me pick a couple others here. So, and by the way, I guess the important part too is that the red here means, the red is it actually removes something. The orange is just warning. So the orange errors here, it will still go across. For instance, output geometry has naked edges. That just means that it's an open object, not a closed object, which is usually not a big issue. But, and the red's a problem. Let me do this. Let me try this one. And build to build, we try to make this better. So it's sometimes hard to find an example because we are getting better at doing it. Okay, so this is a good example here. So I rebuilt this model here was having trouble at one point, this back cushion. And so what I did was I rebuilt it using quad remesh. I don't know how many of you know that, but there's a quad remesh command that you can go and it will actually fit quads to the object and then either build sub-D or NURBS out of that. And so you can see I could take that and now there's no errors. It actually created the direct shape in Revit, which is great. This went black, which means that it actually changed the Revit database. And if I go in here, that's from above. Yeah, so there's that model. Okay. But if I go in here, you can see that I'm getting a warning, right? The warning is that it used SAT. So in that case, it's actually not a big warning because geometrically, those are the same. The only difference is I used SAT, which means that if I look in the thing here, you can see how it's saved in SAT. It successfully saved in SAT. You can imagine if you see lots and lots of these, it's just, it takes longer to actually do that piece. It also means that there was something about this geometry that it rejected. The initial translation got rejected by Revit, and so we used SAT and that got across. So the piece to understand here is if you're seeing this use SAT a lot, it means your transfer is slow. If you're seeing errors here, if you get the red errors here, more often than not, it's going to be edges that are under 1 millimeter, or you didn't model to tolerance, and you just need to fix the model based on this document that we have, this guide right here. So it talks about, you know, how to do it, and you know, finding bad objects. So there's something called solve bad objects in Rhino. You'll find the bad objects, and you can explode them and rejoin them, and a lot of times that'll fix it. Any questions about that? Does that make sense? We see it all the time.
Yeah, this is Matthew Bro from Henda Architects. One of the ways that we found that we use this is like in early kind of schematic design, moving over, like, you know, doing facade design in Rhino and then being able to put it into Revit momentarily to kind of document it, and then delete it before building, you know, ultimately Revit families. And with that process, we're typically moving over like 20 or, you know, 20K, 30K pieces of geometry. I was wondering if there's any possibility or plan to, like, I know that the component kind of highlights the pieces of geometry that might not pass, you know, that might get bounced to either SAT or fail. Is there any chance of maybe adding an output that would like give you the indices of those geometries or something? Be helpful for selecting the stuff that sort of didn't make the cut and then being able to go back in and edit it.
I used to do that. I actually used to do that by when it used to go to a mesh object, when it was in there, then I'd find all the mesh objects and I'd index it out, and I could find all the bad objects. Kike is online. Is Kike still around?
Yeah, I'm here.
Yeah. Do you know of a way that we can flag and tag things that either got rejected or dumped altogether?
Oh yeah, we can output a boolean like a success, true or false, or an index as well. Yeah.
Right, but we don't have that yet.
No, it's not there.
Okay. Well, Matthew just got that added to the list there, so we'll put together an object. We used to do that when with some other ways of doing that, but yeah, that would be good to do.
We talked it also about, because the problem here is that there are so many components that might take a VREP and they want to generate a solid as an output. And we talked about creating a component that it's purely for auditing geometry. So if you found that problem, you can drag and drop another component that allows you to audit that geometry and would give you more information about what edge is out of tolerance, what VREP is wrong, or something specific more, instead of adding this success or index output in all the components that are converting.
Yeah, I think either one would be really helpful for that use case. You know, if it was, I've noticed the design pattern in some of your guys' other components where there's like a hidden parameter that you can add to the ZUI that, like, you know, adds that additional information, or, you know, if you had an audit, yeah, like if there was one on the output side that was like, you know, gave you a text string telling you what, you know, if it worked or if it went to an SAT or if it failed or something, then you could, you know, you could do some list management stuff on that, or an audit, or really anything that addresses the use case, I think would be flexible enough to help.
Yeah, an audit element like this, but actually had output, because then you could also, you know, if you saw you were having trouble on this level, you could just do that and it would start giving you all the information from that list. Yeah, either one of those would probably work. Yeah, we'll see if how it impacts, you know, how it impacts these versus these. Yeah. Okay.
Thank you.
Yep. Any other questions about this? So this is probably the thing that I see more often than not. Like, let's say you have a custom facade and you have 500 objects and 10 of them are bad. You know, those are a real pain sometimes to fix. So, you know, it's just in certain corners, things were a little sloppy modeled or something like that. Anything else?
I think we can slowly move to the API stuff if
Okay.
nobody has any questions.
Okay.
Because I have quite a lot of stuff to cover, I guess.
Yeah, we're gonna make this. This is an all day. Isn't this an all day workshop now?
Yeah, I know. Yeah, we should.
So, here, let me stop sharing. So,
Perfect. Okay, let's go start talking about Revit API. Let me get stuff out of the way. Okay, everybody see my window? Okay, let's talk about. I guess in this part of the workshop, we really want to get you familiar with how Revit API works, to give you the ability to sort of like play with those scripted components a little bit better. Maybe understand the ones that are created by others first, and then sort of like try to create your own in sort of like reuse them in tandem with the rest of the Grasshopper components that are provided as part of the Rhino-Inside.Revit to get the specific things that you want done. We shared a page, a Notion page for this workshop. The first part was, there's a couple of like preparation sections and stuff like that that I'm not sure if you have taken a look at, but you just basically need Revit and Rhino inside Revit. I'll show you Revit Python shell, which is a great tool to explore Revit API through Python, and the Revit lookup, which is also a great application to have. A couple of different learning resources that we'll talk about. The first one was Rhino inside Revit that Scott sort of like showed you how it works and the basics and all that kind of stuff. In the next section, we're going to go through an overview of what Revit API is. And the primary purpose, and normally you don't really have to take a lot of time talking about APIs. Generally, API documentation is usually clear. There's like guidelines on where to start and where to end and that kind of stuff. But Revit API is, yeah, I'll share the link to that page on the chat as well. Every time you want to make itself, this edge wants to make itself default. So normally you don't really want to sort of like talk about APIs in too much detail, but sorry, I'm trying to respond to the chat messages at the same time. Thanks, Scott. But Revit API is very inconsistent. So it's been developed over so many years with different mentalities and different ways of developing API. So kind of like trying to find your way through it is very important. I have about an hour and a half, an hour and 15 minutes left. And I want to focus most of it on the examples that we have. So I'm going to go through this section in the next 15, 20 minutes. I'm going to open a Revit model, very sort of like simple, empty Revit model. And we're going to talk about, I'm just going to draw a wall in it, or a couple of walls. So I have a level in here and a couple of walls placed in the Revit model. Man, why does it get stuck? Okay. So if you install the add-in, and I highly suggest just have this available at all times on all your Revit versions. The add-in is called Revit Python shell. I've linked it into the page. It basically gives you a shell, or sort of like a terminal environment, terminal looking environment into Revit API. There is, so if you go to the setup option for this, the configure option, on the last tab, init script and startup script, you can specify initialization script. So every time you run Revit Python shell, it sort of like goes through that initialization. I have an example of this init script that I use for myself that I've shared on the Notion page that you can set up and sort of like put the path in that sort of like in that box, and Revit Python shell will run that script every time you launch it. What it does is that it sort of like provides easy access to you for like the document. So it sets up all these variables on the initialization, and it imports Revit namespaces. So we've got DB and UI namespaces already pulled in. And we'll get sort of like we get to a little bit more detail about that. And then if I have an element selected, once I go to the Revit Python shell, if I type EL or E1, I have the first element or the element that is sort of like selected very easily accessible through here. So it makes life a little bit easier. So that's sort of like what Revit Python shell is. We want to talk about a couple of things that are super important when working with the Revit API. First of all, Revit API has two different sort of like major sections. One is the one that works with the Revit content, the content of your model as a database. That's called DB. And the rest is called UI, and it works with everything that's related to the Revit UI. So if I want to add a button to the Revit UI in here in my add-in, I'll use the UI API. If I want to work with the walls and the contents and all that kind of stuff, I use the DB namespace that's related to the database. A great resource for this is a website that's called apidocs.co. There's another one that's sort of like a little bit older. It's called Revit API Docs. Both developed by the same guy, Guy Talarico, that used to be working at in New York, I think at WeWork, and now he's in Airbnb. But sort of like these two websites are a great resource for API documentation. I tend to use API docs because, I don't know, it looks slightly different, maybe, I don't know. What's great about it is that you can see all the API documentations for the different Revit versions, and that's incredibly important because Revit is not, most software generally sort of like expects the user to be on the latest version. Revit is one of those applications that you have multiple versions of it installed on your machine at all times. So if you're making a tool for Revit, you kind of have to be aware that this tool is going to run in multiple different Revit versions. So you kind of have to know which APIs are available and how they're different from each other in different Revit versions. Like for example, I've selected a type in here that's called Forge Type ID. Let me actually make this page a little bigger. Forge Type ID, and this is sort of like the new typing API, the unit types API in Revit that was introduced in Revit 2021, and you can see that that button, that sort of like circle on the side, is green, meaning that that API, that type, is available in that version, and sort of like ongoing onwards is sort of like available in 2021.1 and 22, but it's not available in any other older Revit versions. So it's kind of like important to know what to use and what not to use. And the Revit API documentation tell you a lot of this stuff. So if I go to, I think, unit type enumeration, you can see on sort of like when you select the type in the description and the example, you can see there's an obsolete message that this enumeration is deprecated in Revit 2021 or whatever version. So always look out for these. This means that Revit API will notify you that this type is being deprecated, and it will be removed in a future version. And it also gives you sort of like a note at what other type ID or what other API you can use instead, or you're supposed to use instead. That means that your code has to change if you want to support a newer version, or you have to put selection clauses that says, hey, like if this is a Revit version 2020, do this. If it's not, do something else. So just be aware of having a really good resource like this to be able to sort of like be able to see the differences in the API is actually really important when working with Revit. Revit API sort of like has a lot of different namespaces. I'm gonna go, so we talked about the database and the UI namespaces. And if you look at this, try to not see anything that says Autodesk.Revit because they're all the same and across all the namespaces. Look at the third sort of like piece in here that's called DB. And you can see there's a lot of sub DB namespaces, and there's a series that's called UI. There are a couple of like exceptions and sort of like, you know, things outside the box, which is not super important at the moment. But generally know that sort of like it's DB or UI that you're trying to work with. UI has stuff for example, UI events. Like if you want your application to listen to things that are changing in the UI, like a view being activated, stuff like that. Or you want to be able to sort of like create a combo box in the Revit ribbon, or like, you know, a push button or stuff like this, like push button, things like that. All of that information, all those types, and the sort of like the APIs to make it work is available under the UI namespace. Everything else you see here is DB, and you can see depending on the discipline, it's got sub namespaces, so mechanical, plumbing, structure, Visual is all about rendering stuff like materials. Materials API is basically db.visual namespace. IFCs, all the events that are related to the document itself. We're not talking about UI here, we're talking about the document. For example, a view is being exported to a different format, or work sharing progress has changed, or the file being imported into your model. So there's a lot of like these events that are also available to you that your scripts can listen to. Electrical is another namespace. Architecture is one of the important ones. And sort of like the root one, which doesn't have any sub namespace, has by far, I think, the most types are available here. You don't generally go through sort of like the namespace list in here to find the type. There's a really good search box in here that you can start searching for things. Like if I want to know, find a type that wraps the walls in Revit, I can search for wall class. And in this case, I can find something here and it'll take me through it. I can see the type. I can see what namespace it belongs to, Autodesk Revit.db. Sometimes it might be something else. So if I look for room class, for example, select the room class and look at its namespace, it's db.architecture. So make sure sort of like to be aware of this whenever you're using this in your scripts. You might, think that, hey, I can't see the room class in here. It might be in a different namespace. And then just like any other API documentation, it shows you all the members, all the methods that belong to this specific type, and all the properties that belong to this specific type. If you do not have any experiences with object-oriented programming languages, this is going to make things a little bit harder. But generally, know that sort of like each one of these types, like room, is derived from a sort of like a more generic type. So in this example, the more generic type is going to be a spatial element that's linked right in front of it, right? So if I look at in spatial element, I can see, I can see there are three other types: architecture room that we talked about, area, and mechanical space. They're derived from that type. This sort of like the driving process means that it sort of like grabs all the properties that belong to the spatial element and adopts those, right? So if you're looking for something in room and you're not actually seeing it, maybe go to the room members first, because this way, this list shows you anything that's also adopted from other sort of like the hierarchy, the more generic type. And then you can see there's a lot of stuff that are actually adopted from element that we talk about. But the methods and the properties only shows stuff that are defined on that very specific type. It's sort of like a more easier way to do this is to use the auto completion inside the Revit Python shell to kind of like find those properties and whatnot and see what's available. And I'll show that to you. So this is sort of like the major differences between the DB namespace and the UI namespace. Just know that most of the times we're going to spend our time working with the types inside the DB namespace. There is an instance, there's a type that sort of like wraps the actual Revit application itself. And there are two different types of that. There is application class. So if I search for that, you can see that there's an application under creation, Autodesk Revit.creation.application. And there's another one that's called the UI application class. These two sort of like wrap the two different purposes of the application. One is about the sort of like Revit as a database manager that takes care of your Revit models and the database and all that kind of stuff. And the other one is Revit as a graphical application, the UI of Revit, and some stuff that are related to the application level that are important. We don't get into too much details about it, but just know that whenever you see these two in the API, there's going to be UI application and there's going to be application, and these two are different from each other. The most important thing about the Revit document that we're working with is a way to sort of like reference that document. And that is done through db.document class. So if I search for document class, and you can see there's one that says Autodesk.db, Revit.db document. This holds the reference to the project that you're working with. It's not the active document, it's any document that's open, right? So any document that's open has an instance of this document class that sort of like you can use. I'm gonna go to Revit Python shell here. And I've set up that document in here. So if I say doc, you can see that it sort of like gives me that this is the Autodesk Revit db.document. And doc is automatically set up to be the active document in my initialization script for Revit Python shell. Revit Python shell will give you access to this Revit, under Revit variable, that is the UI application, right? So it's the application, sort of like the UI instance of Revit. And through that, I can get access to the application, which is the DB sort of like side of the application. And I can, through that, I can get the active UI document, for example, the document that's active in the UI. And through that, I can actually get a handle to the document that is the DB document. So you can see that just like the DB and UI and the UI application and the application that we talked about, document has a UI document and a DB document also in two different namespaces. The UI document is the visual aspect of that that model that's open. So like what views are open and what's the active view and stuff like this. And the DB document is actually the handle to the database of that document. So that's where all the elements and everything else is stored, and that's how we sort of like use that. And I'll show you how these work in the example. I'm giving you multiple different examples to kind of see that the API in Revit is split between what's in the UI and what's the actual sort of like the database. Let's call it the front end and the back end kind of situation, right? So if you see these names in multiple different places, don't be confused about it. So whenever we want to work with a Revit document, we need to be able to have a handle to that DB document. Because all the Revit API pretty much that makes changes or reads something from the Revit model, they need a handle to that document to kind of see which document you want to work in, right? So if you have multiple different documents, I need a way to be able to grab all the open documents. And I think it is, I think it's on application documents. Yeah. So part of the application properties is a property that's called document, and it gives you a document set. You see it's inside the DB. It's a different type. It holds a collection of the documents. So this is how I can get all the available documents in Revit that are open to me, right? This includes documents that are not sort of like open in the UI. Because a lot of times when you open a Revit model, it has linked documents. And in order for Revit to be able to actually load those contents inside the host model, most project, it needs to load all those documents, right? So if you have one Revit document open and it has 3 other models linked in, you actually have 4 documents open at a time. One of them has a UI document attached to it because it's open in the UI and you can see it. The other ones don't have a UI document. They're only open in memory. And generally the way in Revit works is that because they're linked in another sort of like project, you can make changes to those documents. So it is important to know what you can do with these documents. So if I try that document again, and sort of like a lot of times if you want to sort of like know what is available within those type, Revit API has this convention that has properties that their names start with is. So that's a sort of like a good question. Like I can say is linked. I can use that to when I'm going through the documents in memory that are open in Revit, I can check this way to say if that document is actually a linked document, right? Not a document that's open in the UI. Or I can say, is it a family document? This is also a very important notion to kind of understand that in Revit UI, the Revit projects and Revit families are kind of represented slightly differently, especially in the project browser because its limitations are different. But from the standpoint of the Revit API, both of these families and project documents are actually represented by the same type. The only difference is that check, the is family document returns a different value if you have a document open. So sort of like that's the major differences between the two different types. All of this stuff that I'm actually showing to you, they're available through that initialization script that will give you access to Revit API. So I'm going to open this in here, and sort of like you can see how I'm importing some of the APIs that I need. And this is mostly R and Python. You don't have to worry about it too much, but you can see that I'm importing the DB and the UI namespace from here, and sort of like getting a handle to the application of Revit using the Revit, which is a Revit Python shell thing that it provides for you, and sort of like some functions and whatnot in here. So we talked about the document. The next most important thing in a Revit document is that Revit document is actually a database. Always try to think about Revit document as a database. It makes your life a lot easier. Everything that you see in the Revit model is basically an entry somewhere inside that database. So imagine, sort of like just visualize this. I'm not saying that this is exactly how Revit is actually built, but thinking about it this way makes your life a lot easier. Think about, there's a table inside the Revit's document that says, these are walls table, right? And this table has, it's like a sort of like an Excel spreadsheet, and it has certain properties that are specific to walls. It doesn't have anything that's extra. And inside that table, there's a line for every wall that you have created in your Revit model, right? And sort of like when you schedule the walls, that kind of represents that kind of the information inside your database, right? And you get to see what properties and whatnot are available to you. All the Revit geometric types, everything that you see in the Revit model, and even a lot of non-geometric types, are represented by a parent type that's called element. So when we talk about elements in Revit, this is what we're really talking about. We're talking about db.element. db.element is the parent class to a lot of different types. Most of the stuff that you see in a Revit model are placed in here. So if I, for example, if I want to look at wall, I don't know if this lists everything, but let's look at, I think that's part of the host object. Let's see if I can find host in here. Yeah, host object. So element class is a parent of host object, and host object is a parent of wall. So it's not a one level hierarchy. You get a multiple level hierarchy this way, right? So the root of most of these is db.element, but you got host objects, you got all sorts of different stuff in here until you get to the actual type that you want to use that represents your element. In this case, it would be a wall. Revit API is missing specific types like this for a lot of its elements. So a lot of times when you look at something and you say, hey, like for example, if I select the wall in here and I go in Revit Python shell and I say, what is this wall? It's going to tell me that it's a DB wall. A lot of times you select an element in Revit and it just tells you this is db.element. That means that they haven't really created anything specific for that geometry or whatever that you're seeing in a Revit model, right? So just know that this is one of the inconsistencies in the Revit API. Not everything that you see here has a specific type. So just know that. Basically, I guess that's the most important thing that you want to know at this point, that everything sort of like gets derived from DB element, and there are specific types for some types. Not everything's available through that. The other part is that, well, we talk about sort of like when we talk about tables and databases and all that kind of stuff, every entity in that database needs a schema. You kind of have to explain what properties are relevant to a wall so you can store them in the database, right? As a Revit user, we are very familiar with this properties panel. We see all the properties of the wall in here, and they're in two categories. For every Revit instance, sort of like piece that you see, we have instance properties and we have type properties. Sorry, clicking the wrong thing in here. We have type properties. And some of these types are actually very complex. Like structure is its own thing. It's not just a simple integer value or a string value and stuff like that. That parameter has its own settings and properties and all that kind of stuff. So manipulating these complex data structures sometimes is easier through the UI, because I can just come here and select a bunch of things and be done with it. But when you actually want to work with this through the API, that's actually a lot harder, because you have to create the type and grab the right values and query the right values and set the parameters in the right places and all that kind of stuff, which a lot of those stuff are actually handled by the UI. So you kind of have to pick and choose your battles. When you want to automate, like for example, placing a variety of different wall types in your Revit model, maybe it makes more sense to kind of make those Revit wall types in a template model and just grab that type and place it in the Revit model somewhere, instead of actually programmatically try to create all those different types and stuff like that in your Grasshopper definition or in your Python scripts. So that's kind of like you have to pick and choose where you want to land with this. I would suggest for best performance and best experience, if there's something that you have to make like only once and twice, kind of like create it in the UI, place it in the Revit model. Maybe like there's a family that you have to create that you want to sort of like populate the model with. Maybe create 1 or 2 instances of that family with that is parametric enough and has the right properties, and use your script or Rhino-Inside.Revit to place it and set those property values inside your Revit models. That would be a decent approach. One of the most important things to know about the properties of these types is that these properties that you see in here sort of like are stored in a different way in Revit. So a lot of us that sort of like have experiences writing, working with programming languages, you know that this type has a series of what we call properties. So if I say EL width, I can get the width of that wall from the properties that are defined on that type. So if I go to the wall class, I can see on the properties, there's width that's defined. But I know wall has a lot of different parameters in here in the Revit parameter viewer. This is also sort of like called properties, but once we get to the API, we tend to talk about them as parameters because that's what the Revit API calls them, right? So that's why you see parameters mostly in the Revit, in the Rhino-Inside.Revit components and all that kind of stuff, because it's really talking about these. In C# and .NET programming languages, these are called properties. And there's a very sort of like strict difference between the two. Not everything that you see in here is exposed through the object or the type properties that are defined here. Like for example, the wall has a width, but doesn't have any height, which kind of doesn't make sense. Then that's one of the other sort of like inconsistencies with the Revit API. Not every parameter that you're used to seeing in here is actually exposed through the API. So how can I get, for example, the height of this, which is called the unconnected height, and sort of like start working with that? The way to do it is a method on the db.element. So it's kind of available to all the elements that's in the Revit API. As we talked about, db element is the parent. Every other subtype, drive type that we talk about sort of like adopts that functionality that's available as part of the db element. There's a method that's called the lookup parameter. So imagine all these parameter information is stored separate in the Revit DB in the document. They're attached to this wall that we're working with. And we want to look up what is the unconnected height parameter on this element. And it returns a value that's a db.parameter. So even a parameter that I see inside that, that parameters panel is represented by a very specific type. And I'm going to look at it here in the documentation. And I can see there are lots of methods available to it. And sort of like it has its own set of properties. So I'm going to store this in a variable here, and let's start working with it. Like I can say, I can inspect what is the storage type of the parameter. In this case, for uncollected height, it tells me it's a double value, right? The storage type has other types. There are actually 4 really important types in here. Either it's an integer, and what's confusing is that all these yes, no parameters that you used to see in the Revit API right here, all these yes, no's, or like Booleans, sort of like these, they're actually represented by an integer. So it's like a 0 and 1. That's another level of inconsistency and it makes it a little bit worse. So don't get confused if you see 0 and 1 coming out of those values. Double is floating point values, string information, and everything else is pretty much element ID. So if I go to, for example, open a model in here, that let's talk about the elevation tag, for example. When I'm working with a elevation tag, and this my row is kind of behaving different. And I'm working with a type parameter in Revit for elevation type that's called elevation tag. If I export the storage type for this, it's going to tell me that this is the storage type for this parameter is an element ID. This parameter doesn't store the name of that elevation tag type. It stores a reference, which is the element ID to that type, right? That's why every time you see sort of like this selector, in the properties panel that you can actually go and select something else, some other elevation tag type, that's generally a good sign that this storage type for that property is actually a element ID. So there's a lot of parameters that are sort of like belong to the object that you're working with, the element that you're working with, that are actually referencing other stuff. This is one of the most fundamental things about Revit database. There are relationships between elements. When you work in Rhino, you can create a sphere, we create a box, all that kind of stuff. They kind of live in, they don't have much relationships between them. If you make some changes to one of them, it's not going to affect a whole bunch of other Revit, the elements in that sort of like Rhino document. In Revit, it's vastly different. We're very used to this, just working with the UI. If you delete a wall, anything that's hosted on that wall is going to go away. If I delete a elevation tag, all the elevation types that I have, elevation sort of like marker types that I have, are going to get affected. They're going to lose that reference that they have. So this is also very, very important to know. So just know that every time we want to work with these properties in here, it's better to get them through that lookup sort of like function that I showed. Now, here's one huge problem here. As you noticed that I sort of like I typed the name of that parameter in the panel, what was the unconnected height. The problem is that in a German Revit, or a Revit that's a different version, the name of that parameter is different. So the API actually works differently. You kind of have to be aware of that. That's why Revit API provides this enumeration type. I think it's called built-in parameter type, built-in parameter enumeration. So there are a couple of these built-in stuff in Revit that tries to give you access to these sort of like parameters in a standard way. So instead of asking for unconnected height, I can provide the wall user height parameter from that db.parameter enumeration and sort of like look up the parameter from here, right? So I'm gonna grab the name of this, and I'm gonna go to the wall, and I'm gonna go to my Revit Python shell element parameter. And usually the way I look it up is using another property is called parameter that has an indexer. So I can say db.built-in parameter, and I'm going to put that name in front of it. And I'm going to get access to the db parameter for the wall height parameter. So this way, this will work in all the different languages. So if you're writing in script, you want to make sure it works across your offices, different languages, all that kind of stuff. If you're sharing with other people, try to get used to getting the parameter values this way. This is one of the reasons that Rhino-Inside.Revit becomes so valuable, because it handles all this stuff for you automatically, right? You can just provide the name for it or something like that. Or we have selectors for all this stuff in Rhino-Inside.Revit that I'll show you that sort of like handles this automatically for you. So if I go to Rhino-Inside.Revit, I have standard selector for built-in parameters. So the same thing that we talked about. I'm going to search everything that starts with, I think it's maybe unconnected. What is it, height? Yeah, unconnected height. It's the same parameter that we talked about, wall user height parameter that you could use to filter and find stuff. So a lot of these stuff you can see that are sort of like represented by that. Built-in categories is kind of the same. We have something else in the Revit API that is called built-in parameters, built-in categories, category enumeration, that has all the standard categories defined in Revit. So don't reference categories by the actual English name. Use the built-in parameter, built-in category enumeration here, right? So here's sort of like, this is the easy, short description of what the Revit API is. I kind of showed you the differences between DB and UI, showed you there's some sort of like sub namespaces for different disciplines. We talked about the differences between UI application, UI document, and the db.element that represents everything. Anything that's available on db.element is propagated through all the derived classes, so it's available to all of them, just like any other object-oriented programming language. And sort of like, you know, we talked about the differences between properties that are available on the type and the parameters that we are used to seeing inside the Revit environment, and what kind of like values do they store and how we can set them and all that kind of stuff. We talk about more in the sort of like next section that I'm going to talk about because we tend to think the Revit model, the Revit project as a database, we're talking about the CRUD operations. CRUD operations are the operations that are the most basic operations you do on a database: create, read, update, and delete. So in Rhino inside Revit, we tend to call them create, modify, query, and delete. Delete is the easy part. And there's only one function in Revit API that deletes stuff. I'll show you how it works. You got to be very careful about deleting it because we talked about relationships. So when you delete something, a whole bunch of other stuff are going to get deleted. Revit API has a way of showing you that. We'll talk about that in a little bit of detail. But basically, the most important things you want to know is how to query things in a Revit model, how to modify, how to create new things, and how to make changes to the existing or the new ones that we have created. Are there any questions so far?
The only one that I have on chat is what values, what units is the API using?
Oh, so most weirdly, Revit API is built on feet and inches. So it's kind of weird. So like this is a wall that's about 8 inches wide. So if I read the width of that, as you noticed, might have noticed, it doesn't tell me it's 8 inches. It's built on feet, right? So it's 0.66666, something like that. But if I read the sort of like a lot of times, like for example, the height, let's get the parameter dB, the built-in parameter, I think I do have that. Yep. Okay. I'm going to get the height parameter again. I can inspect the storage type of the height, and we sort of like saw that it's double. I can, there's methods on the parameter, on the dB parameter type that lets me work with the parameter values. There's one that's called as double. I can get the value as double. So it gives me that 20 feet. You see that's in feet. But I can also get it as value string. So it gives me the value string that actually shows you in the Revit property window. So it does all the formatting and all that kind of stuff that's available to it. So if you're getting something in maybe sort of like a different unit, you might see the unit type in front of it too. It gives you the value string that actually Revit shows in the Revit UI. So, but just know that the default value that you're getting it's from feet. Display unit type is also here. That's sort of like there's an enumeration in Revit that says, hey, what's the actual display unit type for that property in here that says feet fractional inches, and that's what available in the Revit document. Once you get to the Revit document, being able to work with the document units is actually very important. So the document class has a property, I believe, if I'm not too wrong about it. Get units. So this gives you the units that are the unit configuration for the document that you have, right? And I think there's unit utils or something like that class. Yeah, and there's so there's a whole set of types in Revit API that's sort of like their name ends with utils. I have no idea what they've done it this way, but there's some stuff that are sitting separate on the side to be able to help you with conversions and those kind of stuff. Like you can see the unit utils has a lot of like different conversions from different units and all that kind of stuff that you can use. There's good documentation on a lot of these. A lot of these actually have like examples and whatnot. So you can check those. Also be very aware that the unit API has changed dramatically between 2021 and the older versions. So sort of like any script that you had written for maybe like anything that was before 2021 is going to break on 2022 when they remove the old API. So kind of be aware of that when you're looking at these things. And there's also other conversion util types, like for example, element transform utils is another one. So if you want to transform an element, maybe like see if it can be mirrored, copy elements, mirror element, move, rotate, that kind of stuff. They're all going to be under this element transform utils. So if you don't see the functionality on the element, try to look under utils too to see if there's a specific utils type to make those changes and sort of like search for those things. I think sometimes I use for, yeah, I search for utils in here and it shows me a lot of different utils actually showing up here.
So there's another question here. Some people are talking about struggling with API documentation because a lot of the API documentation's in C#.
Yeah.
And what's your trick or the best ways of translating that to Python?
Okay, it's actually super simple. Let's see. What did I use? Let me see if I can. Hold on 1 second. Let me pull one of my older examples from my notes. Workshop. So the thing is, the Revit API is written in C#, but the C# is sort of like the language that the Revit examples basically are written in C#, but that's just the language that we're talking about. The API is actually built on .NET. And what you're writing, the language that you're writing in, if you're using Python, is IronPython, which has direct connections to the .NET runtime. IronPython is actually implemented in C#. It's the whole Python spec that's implemented in C# that sort of like makes your life a little bit easier. I'm trying to find something, a C# example that I have here. Like for example, this method. Let's see, I have this method in here. And I'm gonna save that as a C# file. Let's say you got this example from the Revit documentation or somewhere else on somebody else's sort of like script, and you want to convert this into Python. There are a couple of things you need to know. Like there are no vars in Python. You don't define the type of the variable that you're defining. So anything that is a var, you can get rid of. Anything that's a semicolon at the end, you can get rid of. Anything that says new, you can get rid of. You almost can write like a tiny Python script that cleans this up for you, right? This is a valid IronPython statement. You only got rid of the var, the new, and the sort of like the semicolon at the end. Again, I'm going to get rid of all these semicolons. We don't need vars. We don't need news. This is valid in IronPython. There's not a whole lot of changes that you have to do to convert the examples to sort of like different types. And a lot of times, like in C#, this is an example for a C# scripted component in Grasshopper. I have to do typecasting to make sure my variables are on the right type, so I can actually use them inside the script and stuff like that. You can just get rid of this stuff in IronPython because Python has dynamic typing, right? So the try catch would be, the blocks would be slightly different, right? The try catch exception as E. Like this is pretty much all you have to do when you're working with IronPython, and it got like none in here. Probably I can get rid of the component. So like very quickly, you can convert your script into a 30 valid, get rid of all the semicolons here, into a valid Python script. Right? There's not a whole lot that you need to know about sort of like the difference between two. There's only the one thing that's kind of important is that there's a lot of times in C#. C# has this convention that you can have output parameters inside your output argument inside your function calls. Sometimes there's a parameter in function definition that has an out keyword in front of it. So C# cannot return multiple values from the function the way Python does. So the way to do it is that they put those values sort of like inside the arguments of the parameters of that function. And IronPython handles that for you automatically. So if you say anything that's out inside the parameters of the function call, IronPython will grab those and will return those as values in front of the function. I think I do have an example of this in the stuff that I'm going to show you. But those are like very minor differences between how IronPython works and how C# works. So a lot of those examples can be converted very easily. You think that answers the question, Scott?
Yeah, I think so. My mind got blown on that. I'm like, wow, I just only had known that before.
Yeah, they're both cool. .NET. The thing about IronPython is that it's got Python in its name, so it's a little confusing. But the reality about IronPython is that's mostly a .NET language. It implements the Python spec, but it can directly talk to anything that's .NET.
Perfect. All right.
Cool.
I think that's all the only questions I have on this on the chat.
Great. I don't have much left, and I have a lot of examples to show. These CRUD operations that I've put in here, anything that we didn't get to it, we can take a look at it by yourself, I guess. But there are zip files attached to each one of these sections. If you want to open those, I'm going to show you a couple of different things about how we can query things in a Revit model. So I'm going to close these models that I have. So find elevation tags. Let's see, I want to find all the empty elevation tags in a Revit model. I have that model open ready for me. Some of them, these elevation tags are empty. All of you Revit users know how easy it is to create elevation tags that are empty in a Revit model. And it's a nightmare that they show up in different places. You got to create filters to clean them up. It's a nightmare. Let's say you want to create a grasshopper definition that does the job of that cleanup for you. So in this example, as Scott showed, I'm using the element classes, which is sort of like a built-in in the filter. I think it's input. Yeah, element classes, that one. And I'm creating a filter to be able to find all the elevation tags in a Revit model. Now, the primary thing and the most important thing you need to know about collecting information or querying information from a Revit model is a type that's called DB filtered element collector. That's all its job. It collects elements using a filter. So it kind of reads the name backwards, right? It collects elements using filters. The primary thing that it needs a reference to your document. Why? Because it needs to know which document you're querying stuff from, right? Once you created this filter, this sort of like collector, let's call it actually. Usually you see in the example, it's called CL, collector. Then you can apply other extended filters to it. So if I go through the API and look at db.filter element collector, and this is one of the really, really old classes that was sort of like created in the first version of Revit. So it's available everywhere on every Revit version. Collector. If I look at methods, I can see it's got, wait, sorry, I'm looking at the wrong thing in here. Yeah, filter element collector. If I look at methods, you can see there's a whole bunch of stuff that they're called of, like of category ID, of class. And then we got where element is curve driven, where element is element type, where element is not element type. We got, like, for example, we got where one that says, and it's one of the most important one that says where passes. So the way the filter element collector works is that you instantiate an instance of this, and then you incrementally filter down the stuff that you need, right? So I can say CL, which is the instance of the filter element collector, and you don't have to write this in different lines. You can actually do it all in one line. You can say of class, and you can use a class that's let's say elevation marker class that represents, that type represents an elevation marker in the Revit model, right? I can say filter any element in that document that is of class this. And the element types in Revit, which is the sort of like the, whatever, like, let's say wall type or an elevation tag type. You know, every element in Revit has instance properties and type properties. So it also has a type. A wall has a wall type. An element int marker that we put in Revit model has an element marker type. Everything has a type. When you filter stuff using that class, or let's say, I don't know, of a category, a lot of times you get all the types and elements at the same time. So if I say filter element, all the elements that are of category wall, then it'll give me all the walls instances in my model and all the wall types in my model, because both of them are kind of like derived from the db.element, and that's why how the Revit API works. And that's why you see these functions, these cleanup functions on it that says where element is not element type, for example. So I want to put that at the end and say where element is not element type. So it filters out everything that's not a type and just gives me the instances. And then I can convert that to elements and get all the elements, or to element IDs if I need element IDs, for example. So that's how you sort of like filter stuff. And this creates a collector for you. Now, the collector hasn't done anything so far yet. Well, when you actually convert to element, it creates a list. But generally, the filter sort of like tries to be at the most efficient as it can. And sort of like you can go through the all these elements. If I create a loop in here, I can get all these different 5 elevation markers that I have in my Revit document right here, right? So each time you go through a loop, you get an instance of that. So this whole acts as a sort of like a enumeration type that it will give you. You can loop over. But a couple of things to need to know about the query stuff. One of the most important functions on this is called where passes. And where passes you can pass a filter to it. And these filters can be constructed in multiple different ways. There are like complex ways to do them, but there are sort of like quick filters that return the results really quickly and slow filters that are really slow. One of the examples is that if you try to find all the dimensions on all the sheets in your Revit model, this is going to be very slow, because every time you want to iterate over a sheet, Revit has in the backend has to generate the contents for that sheet and try to get that information for you. So just know, but sometimes there's no way around it. You kind of like, for example, if you want to see if a view is referenced on any sheets, you kind of have to go through every sheet and see if it's referenced or not. Sometimes there are other ways around this to check it, but sometimes it isn't. And so you kind of have to be aware that sometimes these filterings will take a little bit more time. All these different types and stuff like that in here that you see, they are represented with kind of like the same way in the Grasshopper, in the Rhino Inside Revit API, that components that we have created in here. So we can create different filters. That's what it really means. So the class filter and the category filter are basically of class and of category of the filter element collector that we talked about. So when I create a class filter, I'm basically doing exactly the same thing. I'm creating of class of DB elevation marker. I'm creating a filter and then pass that to a query elements, which is the collector, right? Collector this way. I'm passing that filter to it and say collect all the elements that are of that type, and it returns all these 5 elements, just like the way the collector function did. This is pretty much all you need to know. This DB element filter element collector, all you need to know about how to sort of like filter elements. There is on the PyRevit, I'm going to show you a good resource for this, wiki.pyrevit.io. If you go under, and I've linked this in the sort of like the page that we have, there are really a couple of really good videos for explaining all of this. Like for example, if you look at Revit document as a database, that's a really good view, and advanced filtering elements in Revit model. In this video, I'll talk about all these different sort of like filters that it can create. Like for example, it would be a lot more efficient if you can create a filter that finds a very specific element by its name, rather than trying to loop over every element that's inside your Revit model, check its name and compare it to the string and find it yourself, right? Revit API has methods to do this a lot faster. As an example, I'm going to show you this sort of like, I'll show you an example after this later to create that sort of like a custom advanced filter in here. But basically, I had this example actually placed in here inside that definition, that you can see that Python scripted component that I have collects elevation tags, that DB filtered element collector of class, where element is not type, 2 elements, and all of that is passed to the admin. So if I use my collectors from Rhino Inside Revit or this, it really doesn't make any difference, right? So we can swap these 2 very easily, and the result will be exactly the same. To check to see if the elevation tag is empty or not, I have looked at what I do is generally like I select the element in Revit, I go to my Revit Python shell, and then type EL in here to see what type it is, right? And then I go find that type in the API, say, okay, so show me elevation marker class. And then I look at its properties and see what's available, what kind of functions are available to me. And there's one that says current view count, which is great. That's exactly what I wanted. I can get the number of views that are attached to this elevation tag. That's great. This is what we're going to use. I've created a Python script in here, very simple inside Rhino Inside Revit. And you see a lot of this stuff at the top, like all this boilerplate sort of like text in here. This is what brings a lot of utilities into the script so you can get to use them. It references it kind of like acts like the init script that I showed you in Revit Python shell. brings the Revit API, Rhino API, Grasshopper API, even grabs the Revit version for you so you can very easily check that in your own script, grabs the instance of a document, has a couple of functions to show warnings, errors, and remarks on the component itself inside Grasshopper. And basically at the bottom of this is what you sort of like where you place your script. And all of this is inside the guides. And if you go at the bottom, there's Python components in Revit. And we have talked about in detail for this, and the whole template and the actual user object component for this is right here. So from now on, when you want to create a script, you can just grab that user object from Grasshopper, put it in here. It has all the boilerplate text in you. It has the right sort of like construct for the transforms. And you basically go here and change your document right here, right? And give it a transaction name. So all of that is fairly ready. What I'm doing in this script is that I am going to, first of all, it's Python, types are dynamic, so make sure always check the right input so you don't get a lot of errors. I'm checking the input, which is called elevation tag, is of the right type, db.elevation marker. That's what it should be. And then if it is, I'll check if it's empty by checking its current view count, whether equals 0 to not, right? So I created and if it's not that type, I'll just return false. So I created a sort of like a filter component that I can pass to call with pattern. I can pass all the elevation tags from this model, use this, call pattern, and I get the ones that are empty. And then I can use the document, or actually element, I think it's delete element, and I can pass it to this, and it would get rid of those elements for me in the Revit model. Another example of this simple querying stuff would be to, let's say you want to find a very specific room in your, and I'm just opening another example. I'm going through this stuff a little quicker so we can get to the more important things. Query room by number, for example. This is an example that I'm constructing a more complex filter. I'm not doing this through the API. A lot of times you don't really have to, the purpose of this sort of like conversation is not to force you to create all these complex scripts inside one component. It's just to play the interplay between what is available to you in the Rhino-Inside.Revit components and what you can create in your scripts. So like I can, through the built-in parameter, I can pick the room number. I can construct an equal rule, and they're here, equal rule. So basically this says, creates a rule, whatever that parameter, which is a room number, equals that value. And I pass that rule to a filter. The filter that I'm using here is called a parameter filter. That's here. All its purpose is to filter by one of these rules that belong to a parameter, right? So you have greater than, you know, the different types of values that you want to create. Even like text, if you want to see if a string parameter actually has a substring in it or stuff like that. And then just like the other ones, I create the filter, pass it to the query elements, and it gives me the room, the only room that has that specific number, right? And I've constructed away this through the API, so it's like super quick and super fast. You have this in your examples that we have shared. Let's move to create stuff in Revit. I'm gonna go to the other folder, create, and we have a whole bunch of examples in here. Let's talk about creating sheets, for example. And for most of these examples, I gotta have to open the Revit model and the Grasshopper definition. And this actually throws an error for me for now, but we'll get past this. Okay, so what I'm doing is that I'm creating a series of sheet names from M0 to M1 using the standard Grasshopper definitions. I have those. These are, I'm sorry, sheet numbers. And then all my sheet names are gonna be named mechanical. And I am creating another filter for a specific category that's called title blocks. And I create a category filter, again from here, category filter, and I pass it to element types. Notice that I'm not using the query elements here. I'm using from types, I'm using query types because I'm not looking for title blocks that are placed on sheets. I'm looking for title block types that I can place on my new sheet, right? So this would be equivalent to, I'll show you where the type is. So I'm sort of like passing that to a a selector component that it's, I think it's this one, the value picker component. So you can pass any of this stuff to here, the name will show up, and you can very easily select that as your decided title block type. And I'm gonna open that script that we have, we're gonna run it, and it's going to create those sheets for us with that name and with that title block type placed on it. This is a title block instance, its type is here, right? So that's what we specify for the type. That's what we do when we change types in Revit. That's the what's called element type. And then, so in the script, I'm not doing a whole lot. I'm running a transaction. Revit API, every time you want to make changes to it, it is a database. You have to make that change through a transaction. The transaction is provided by the DB namespace. It works on a specific document and it has a name. That name is what shows up on your undo list in here. And the transaction guarantees that at this moment, when you start the transaction and before you commit the transaction, you are the only one making changes to the Revit document. This is incredibly important because you don't want two different things making changes to the same thing and overriding each other, right? So just know every time you're making changes, you have to run a transaction. For querying stuff, we didn't run a transaction. You can query all you want. All applications can query at the same time. That doesn't matter. But when it gets to making changes, transaction is required. You create a transaction instance, which is T, start. This is generally how I suggested. Throw a try except block, make your changes, commit at the end. If any error occurs during this, you go to the except sort of like block, and you can show your errors, and you have to roll back your transaction. You have to tell Revit that some error occurred, roll back anything that I did. And I have all of this boilerplate built into that component for you to take a look at. In this example, I'm checking the input type for family symbol. Family symbol is another type that represents the type of a family instance, right? They're called in the API, they're called symbols. And then I'm using, if there's a title block provided in that title block parameter, I'm using DB view sheet that represents a Revit view, Revit sheet. And there's a create function on it on this document with that title block ID. And if it's not provided, I'm sort of like providing an invalid element ID. There are a couple of really important things in here when you come to creating components in elements in Revit. There are two ways you can create things in Revit. There's an old method that it is available through the creation namespace, document methods, and there's a lot of functions that says new different things, like new floor, new gutter, new room, new, and some of them are really named stupidly, like new room and then new room 2. So they have different signatures. They can do different things, right? And then a lot of other stuff. This is the old way of creating sort of like components in Revit. In the sort of like API, you can access that through doc.create. Then you get to new functions, right? So this is not how he intended it to work initially. But over time, that thing changed. So a lot of the new API, like for example, if I want to create a wall, I find the wall class, and then I go through its methods, and there should be something that says create, and it has different signatures, right? So for a sheet, which is a view sheet class, create has one signature basically, just that. And in the explanation, in the documentation says, hey, if you provide the ID for the title block, it'll be used. For no title block, pass invalid element ID. Every time you see this, know that element ID that is represented by the element ID class, I'm typing correctly, has a property that's called invalid element ID. So every time you want to tell Revit that, hey, I don't have anything for this, every time you ask for element ID and you want to say invalid, that's how you use it. Every time Revit wants to tell you that this is invalid, it'll return this value for you. That's usually equal to -1. It's integer value. So that's basically how you could create Revit sheets very easily. So you have, it's fairly simple. Like you got create stuff. And if you can't find this create or the new method on it, that's pretty much a really good indication that you can create that type in Revit. Like for example, we didn't have anything for ceilings before Revit 2022.
I have a question about back on the filtering piece. Is it any different filtering for elements out of a linked model?
Yeah, so you remember that the DB.filtered element collector had a document input. So if you want a linked element, you just pass the linked document in there, and you can filter anything you want from a linked document. That's all there is.
And just to clarify, I just want to, I'm gonna it's true we can find out information from a linked document, but you can't transaction back into a linked document, correct? And actually change it.
Linked documents you can query all you want, but as long as they're linked inside another document, you can make changes to them. You have to, through the Revit API, open it in the UI, be able to make some changes to it, close it, reload it back again. It's kind of the way the UI works.
Yep.
So it's a slightly more complicated that way.
Yep, thanks.
Two other things that I really wanted to show. In this example, I'm actually going to delete this one. Well, let's keep it. I have a very simple, sort of like kind of crazy topo in here. And let's say I want to place elevation tags, spot elevation tags in this view on this. I'm going to open Rhino. Well, we have Rhino open, but I'll open Rhino window, and I'm going to load the mesh for that. Topo. And you can see that it's kind of like a super simple mesh. And I've created it in a way that's sort of like grid-like, so we can place those elevation tags nicely on it. So that's there. I'm closing Rhino window, but Rhino is still open in the background, right? The UI for Rhino is not visible. It's just hidden, but it's still the same Rhino running in the background. In the Grasshopper, I'm going to go open that topo spot elevation example. And I should have disabled this because now it creates all of this and it didn't want to. Oops. Okay. So one of the weird things about Revit API is that you kind of have to figure out where things, some things are possible or not. I'm grabbing the mesh from Rhino, passing it to a component that we have in Revit in Rhino-Inside.Revit for topography. I think it's site. Yeah, add topography from mesh. So it creates that topography in Revit model for me. But then I've created a small Python script that basically checks whether that topo is of db.architecture topography surface. Explain to me, why is it sitting under our architecture namespace? I don't know. Inconsistencies. You have topography surface, and I've noticed that the topo type, which is the db architecture topography surface, has a method that's called get points. So I can get the points on the topography. I'm getting those points and passing them out to the list. These are all the points. These are the points that I want to place those elevation tags at. I have grabbed the reference to the sort of like a single instance of this elevation tag that I have manually created in the model. I've noticed through my research online and sort of like trying to figure out how to create elevation tags is that there's really no easy way of creating spot elevations. You kind of have to copy an existing one. And that's one of the typical workarounds in Revit model. Like, for example, you can't create a legend using the API. You have to have at least one legend in your Revit model, be able to duplicate that view and create your new legend and delete its content, put the new content in. Revit API is inconsistent. Not everything is available to do it. So make sure sort of like do your research before you're actually coming up with the bigger plan of how you're going to go about creating something. Sometimes some elements you can't really create them in the Revit model. I'll put a link in the in sort of like the workshop page to this workaround for creating spot elevations. That's an article on in response on Autodesk forums that people have come up with. But basically, I'm starting a transaction in ensuring, again, as always, ensuring the input is of the right type. In this example, is a spot elevation. How did I know that? I selected that spot elevation in Revit model, opened my Revit Python shell, inspected what type it is. Starting a transaction. I'm using DB element transform utils that we talked about. It has a method for copying elements. So on the document, I'm copying my original create a spot elevation to a new location. And I'm doing a little bit of a math to kind of calculate the offset from the actual one. And that's basically my new element. And that's pretty much all this component is doing. It loops, it runs transaction, and creates new elements. So if I run this, you get all the new element IDs in here. And it basically copies that original one into all these different locations, and each one of them is showing the right elevation for that topo. That would be another simple example of how you can create something in a Revit model. Another example would be creating a family parameter that we talked about. I kind of want to show you this because we talked about it in the questions. I'm going to close that one. I guess it would help to get the keep the solver disabled when we work through these, just to be able to explain it before what we want to do. So in this family that I have open, all I want to do is that I want to create a custom parameter in here and sort of like be able to set its values and stuff like that later. In my Grasshopper definition, I have a reference to the active document passing to my Python component, the name of the parameter, the built-in parameter group, and sort of like I created this as an example for this class. So I used this thing that's called a value picker, right? Oh no, not this one, sorry. This other one is called a value list. The value list, the standard value list component in Grasshopper, you can edit this and you can put all these standard values that you want in there, right? So for me to have a nice value picker for one of those enumeration types in Revit, which would be the built-in parameter group, or like built-in parameter that we have shown you before, there's a lot of enumerations like that. I also gave you a sort of like a little tiny Python script in here that you can copy, come to your Revit Python shell, run that script here with the right enumeration type, and it would generate, the sort of like the textual input that you need to place inside that value picker to get those values populated, right? So now you have a nice selector here for that. Same thing for the parameter types, what kind of data type it is, and if it's a instance or not. Inside my script, all I'm doing, aside the boilerplate, again, running inside a transaction, and this time, instead of sort of like checking inputs, I'm making sure the document, the active document, is actually a family document, right? And then I'll run a transaction on it. I didn't really do a good job on this. I had to fix the name and stuff like that. But basically, I'm using the document family manager to create a parameter. So the document type has a lot of stuff that are related generally to the documents, but it has a property that's called family manager. And that gives you access to the family manager class that manages anything that's related to the family. And it has a lot of different methods. One of them is to be able to add a parameter. Add a parameter, it needs its name, it needs its parameter group, it needs its data type, and it needs to know if it's instance or not. Just like the way you create a parameter from the Revit UI. You kind of need to know the name, the group that it shows up in, the sort of like the type and all that kind of stuff, the data type, and if it's an instance or type or not. That's all we need. So we close that one. Sorry, I'm moving a little too fast, I think. And I write that, I sort of like call that method and collect the parameter, send it to the output, and that's all I'm doing. If you run this script, it creates a family parameter for me, and you can see the instance is db.family parameter. And if I go to my family selector, I can see that custom parameter. It automatically shows default because it's an instance parameter and it's defaulted to the set value. The family parameter has all the other methods that you need to set the parameter values and all that kind of stuff on those parameters. Just notice that when you're working inside the family, when we're talking about a specific parameter, for every type, if it's a type parameter, it has a different value. So when you want to set the value of a parameter, when you're inside the family, you got to provide the type. It says, which type do you want to set this value on? I can create different types in here. And for every different type, the parameter, if it's a type parameter, it can have a different value, right? If it was a type parameter, in this one, I can say 1. In the other type, I can set it to 0. So just know that when you're working with families, that's how it works. Revit has a really good tool that sort of like has a lot of boilerplate example Python code to work with family parameters. This is how you can create a lot of like typical parameters in a family. I kind of want to show that dimension to you too really quickly. in the last couple of minutes that I have. I got 3 lines in here. I have grasshopper definition. I'm going to go through open and create a dimension. And I'm going to run this. I've created a Python component and I've placed it in 2 different places. It's the exact same thing. I'm grabbing those lines from my Revit model. In this simple example, I'm sort of like selecting them manually, but you don't have to. And inside of this script, all I'm doing is that making sure all the instances, all the inputs, line A and line B are of DB model line, which the type for model lines in Revit. Sometimes Revit API, like for example, if you want to use the document create new dimension, and this is an example of the older methods that we talked about. Sort of like the dimension in type in Revit doesn't have a create method, so we have to use the older method. It's called new dimension. It needs a view to create the dimension on. It needs a line, which is basically the axis for the dimension line, and it needs a set of references to create a dimension on. Sometimes Revit API requires references to elements instead of the actual elements. In a lot of cases, that's because it kind of needs to access sub-elements inside that element. Just to know that I won't get into the references in detail here, but there's a type that's called reference, and it can create it by passing the elements that you get as an input to it. So in this example, I'm creating 2 references to the line A and B, creating a reference array, adding these 2 to the reference array, and passing that reference array to the new dimension as it needs. So I'm basically taking 2 references to 2 lines, the axis for the dimension, and sort of like go about it. And then the rest of this, I'm grabbing 1 point on one of the lines and calculating the nearest point on the other side. So I can draw the dimension from sort of like the top of this line to the nearest point on the other line, and sort of like come up with the axis for the dimension. Otherwise, if let's say provide the 2 endpoints here, it'll draw the dimension from here to here, right? Which would be kind of weird. So that would be another example. And you can see a lot of these examples is just single API call to create something. There's a lot of time sort of like taken to actually prepare the data that you want to pass to that function call. How much time do we have, Scott? Should I show another example?
Well, let's do you have I mean, yeah, I mean, let's do.
Let me just show this. I'll show this
one
to you
more.
guys so you can.
Yeah, something like that. That would be good.
Yeah. So you can run this. Take a look at this as an example as a sort of like a practice after the session. In this model, I have an empty curtain wall. The curtain wall type doesn't define any pattern for the mullions and the grid lines and stuff like that. There's a Revit model. There's a Rhino model that has a whole bunch of curves in it. It's create grid from lines. And I want to put this pattern on that curtain wall and create sort of like grid lines. There's a grasshopper definition with the same name, create grid from lines. What it does is that it grabs the lines from Revit, from Rhino model, grabs the sort of like calculates its bounding box or something like that, or its plane, and then grabs the wall Revit curtain wall from Revit, calculates its plane of the wall, and projects all these lines on that plane. And then it uses that to sort of like create the grid lines. And you can see all of that in this Python script that's marked with orange. And you can see, again, it's a very sort of like simple, most of this is just fluff, the transaction fluff around it. But with one call to add grid line from current grid, you can create a grid in a certain direction at a certain point with some options. So most of the time you're actually calculating this. And then once you created the grid lines, you can place the mullions and at the end of them, remove the segments that you don't want. So when you create a grid line, like along this line, Revit creates a full line. So you have to go about hiding the rest of them in here. And if I run this, I get that pattern shown on the wall with grid lines and all that kind of stuff in here. So it splits those panels properly. So I'll just leave this one as an example for you guys to kind of look at it after. Any questions? There's a lot that we didn't talk about, but it's kind of like not a whole lot of time to talk about Revit API. It's just big, and for every different type of data type that you want to create is kind of different to go about.
That's actually kind of one of the challenges with Revit in general. when you're even running from Rhino inside Revit is that learning the behaviors of Revit is complicated because different families, different categories, different elements have different behaviors. And so part of this both in the API stuff and in Rhino inside Revit is you really have to just engage in it and work through it and ask a lot of questions, ask us on the forums, and we can continue to bring you along in terms of understanding kind of all this complexity of Revit. But it is the power of, as you get more familiar with it, is by far the most powerful thing you can understand as you're trying to work with Revit. Are there any questions people have? I mean, other than 1,000 of them, but.
Thanks, guys. This is amazing. I really like the last example of the grid lines on the facade, because that really shows like where you can use the power of Rhino and the geometry engine, which is just so much superior than anything in the Revit engine, and to actually bring that back across. You can publish these little grasshopper scripts as like buttons in Revit as well, right?
Yeah, so we're working
like the Rhino player, let's say, right?
yeah, we're working on a set of components for working with turn walls and be able to add mullions and grid lines and that kind of stuff too, though. But the biggest challenge with that is that, like, how do you specify the workflow and the pattern? Because, like, depending on the pattern, you want to go about it differently. So that's sort of like most of the challenge.
No, I get it, but I'm thinking as well, like, I mean, within Core Studio, a lot of it is that we're setting up workflows, right? And there's just a different set of levels of users, let's say. So I already see a set of users like the core Revit users that just want a button like clean those tags up, let's say, right? Like remove those empty tags, stuff like that.
So one of the things that we have added in Rhino inside Revit was sort of like a way to load your grasshopper definitions in.
Yeah, that's what I mean. Yeah.
So as long as like one of your team members creates a script like this one, it just builds a sphere, and I can just run it. And if I control click on it, it actually takes me to the actual definition. So sort of like, that makes life a lot easier for deploying it to the users.
Exactly.
I've provided all these examples on the workshop page. So if you want to grab those components and sort of like start using them in your workflows, that's completely fine. We have a whole bunch of other components inside the, like if I go to spatial elements, there was a question on the poll about getting geometry out of rooms. So this is an example that we have here. There's different selectors and a good explanation on how to get geometries from spatial elements, which is the parent type for rooms, spaces, and areas in Revit. And there's another one for non-manifold merge. All of these are Python components that you can just download and place it in your Grasshopper user objects folder and start using them in your workflows.
Cool.
Do we have a guide on creating those buttons in Revit?
Oh yeah, so if you go sort of like to Python component and C# component, I'm going to go about it from this page. So if you go scroll down to the bottom, there's one for Python, there's one for C#. And both of them explain the process. And the rest of it is fairly easy. Just basically once you came up with, maybe you want to create your own custom Grasshopper script. But once you created that component, you can just say create user object and get the metadata and the icon, and it would create the user object in the Grasshopper's user object folder.
In the Revit tools, the strip up top there, the Revit toolbar, in the interface in Revit.
Oh, they all show up under this custom section.
No, I mean back in Revit, right behind where it says these. Is there a guide how to create those?
How to create these?
Yeah.
Oh, I think so. I have to look at the guides that we have created. I believe so. I'll look at it right now. But it's fairly simple. You just make a folder. In this case, my Rhino inside Revit tools, and I put the Grasshopper scripts inside it that I've created, and I go into options window, scripts, add the path in here.
Yeah, perfect.
And load it
nice.
UI. And they can have their Grasshopper definition. So one of the things that they added in Grasshopper was that if you go to, Jesus, why it doesn't open? If you go to File, Document Properties, you can actually place the icon on the Grasshopper metadata. So it gets stored inside the file, and this will read it from there.
Oh, that's very cool. Is there where is that path stored? I'm thinking about deploying that.
Oh, that is stored in the
Is it
so, yeah, if you can have two different paths. Either it's inside app data, McNeel.
Yeah, depending on whether it's installed for all users or,
yeah, Rhino,
for a single user.
Revit, and depending on the version 1, that's the options file. Or you can have it under program data. And if that option file is there, this whole option button will get disabled. So
cool.
the user won't be able to change it if you have an admin file. What I was gonna say, oh yeah, I was gonna try to find this right here because I know we documented this somewhere. API plugins, components for interface. Yeah, Grasshopper scripts. It's here. All of that is described here on the reference. How you can actually create these.
Nice.
And then the options that I talked about is Rhino-Inside.Revit options is explained here.
That's great.
Yeah, we have a pretty good documentation. Most of the stuff that you want to know about Revit and how things work are here, and we're adding to these. And most of the stuff that you want to know about Rhino Inside itself and sort of like the deployment and the API and the release notes and all that kind of stuff are on the reference section.
Pretty good, you say? I think it's better than the Revit API documentation.
Thank you.
So and on the flip side of if you use PyRevit already in Revit, PyRevit can call into Grasshopper player scripts too. So you can have buttons alongside your Revit scripts using PyRevit and Grasshopper scripts called. So.
Yeah, so I can either run it from here through the player, or if you have PyRevit installed and that's what you're using, you can just throw the Grasshopper definition inside a PyRevit bundle, and PyRevit will ask Rhino-Inside.Revit to run it for you.
Any more questions? We're a little over time here, but
for the curtain wall stuff that you guys are working on, I just wanted to say if it's possible at all to kind of like we use paneling tools a lot, and that's super useful for breaking up facades. If there's any way to sort of like have it tie into that or use some of the same conventions, that'd be really cool. And one of the things we look at a lot also is the topology. So if it could, in addition to maybe creating curtain wall, have some topology schema that it outputs. I know Revit kind of numbers them from left to right, bottom to top, just as a continuous list. But like if the component could return them in a more structured way as a tree, like that information is super useful for doing patterning studies. And then topology between two curtain walls. So like if they're connected, but they're two separate curtain wall objects, it'd be really useful to like know, you know, this curtain wall is to the left of this curtain wall and they're at this angle. So for when we start doing mitering, stuff like that, just as some input for you guys' development process.
Do you find that paneling tools schema works for you?
Yeah, pretty well.
Okay.
The main thing is just the consistency of it. Like we can work with almost anything, and what's beautiful about that system is it plugs into itself really consistently and really nicely.
Mm-hmm. Right.
And then we can just, you know, we know what we have to feed it, or we know what comes out of it, and so having it be cross compatible with that would be really cool, because then it, I think, would expand the functionality a lot.
Yeah, we'll bring Raja in on that discussion, and we'll see if there's any kind of compatibility we could make between the two. That would be good.
Yeah. Currently we have, you can query curtain walls, and you can get a curtain grid from a curtain wall. Mm-hmm. And you can analyze the curtain grid to get the vertical lines and horizontal lines in order, that kind of stuff.
Mm-hmm.
Yeah. Once we decide to lay an additional set of organization, or additional level of schema on top of the Revit API, our lives get quite a bit more complicated because we have a lot more bookkeeping that we have to keep track of. But we'll take a little closer look and see what we can do.
Okay. And if we've played with this a bit in-house too, if I don't know if you guys are curious how people out in the wild are using it, but I'd be happy to to share that on a call or something.
Oh yeah, absolutely. Anybody here, anybody that's doing a project that wants to show us what they're doing and discuss what was challenging and what we could do better, absolutely get a hold of us, because that keeps us. I mean, otherwise we're just in the same four walls in COVID and don't get to see any of this stuff. So yeah, curtain wall stuff we're working on. It's a really good time to do that. So if you have time, please get a hold of us and we can do that.
Yeah, definitely.
That'd be great. All right. Well, we're going to be around on the forums and obviously on Slack. And so I know this was just a quick overview and there's a lot to learn. So please jump into the material that's out there that we put in the notes. Look at the stuff on Rhino.Inside.Revit and then ask us lots of questions on our forum or whatever, however you can get a hold of us. And we can help you along. It'll get easier as you use it. Try it. So, but I think that's the end. I don't want to go too far because I know people have another workshop starting in a bit. So thank you much.
Thanks,
Okay,
guys.
thank you guys.
That's awesome.
Thanks so
Thank
much,
you guys.
That was awesome.